the stream. What transcoder shall I get today? I got the transcoder, nice. Alright, I got 43 minutes to get set up for part 23. Let's make a copy of day 22. Clean it out. So next year I should just have like a template ready. Or maybe just pre-fill it, or have some code generated. There we go. Yeah. To do and to do. With my extra time, I might just go back and clean up some of the previous days. Get rid of that. Hey there, Devil Squirrel. It's going well. How are you doing? I got some time before day 23 unlocks, so I'm just going to be poking around here and there, getting set up, and then maybe go back clean up some old days stuff. Or this could just be a just chatting stream for a while, I guess. Hope everyone watching is doing well. If you're having fun on admin to code, that's good. If you're learning something, that's good. If it's been too frustrating, I'm sorry to hear about it. Yesterday's, and which was day 22, and day 19, I struggled on. So they're getting quite difficult for me. Okay, we need a file called 23.txt. Main needs a 23. I think I definitely want some like runner that packages this up. I'm kind of leaning towards making my own because I like doing that sort of thing. But I gotta think about what I want. Maybe I should just start with studying the ones that are already out there, and if I just like them, I may just use them. Otherwise, make my own. Okay, let me make sure I can run this 2021 cargo run 23.1. We're already on day 23. How about that? You're tired? Yeah, 19 and 22 are very tough. Yeah. You had to sleep on both of them? I kind of gave up. Well, 19 I gave up temporarily, and then I was watching someone else try to solve it, and then I thought of a few things to try, and I managed to get through it. 22 though, I kind of gave up and I knew I wouldn't be able to figure it out, so I got a hint. I figured that if I just made the hint just the algorithm part, don't look at any code, then the fun part for me is to actually write the code for it, and I think that worked out. Although, of course, it would have been better if I were able to solve it on my own. That's always better, right? Hey there, Ace-Cord. Yeah, I started the stream early. I guess I could put it on the Discord, but I don't want to make everybody wait. I mean, puzzle doesn't unlock for, what, another 40 minutes? Another 40 minutes? So today's drink of choice is Samuel Smith Oatmeal Stout. I guess I should just go do the Discord thing before I forget. Stream plan. Today's plan is to not give up or need any hints. It's Advent of Code 2021, day 23. So, A-Squared, how many people do you think actually depend on me posting something to Discord to say I'm about to stream? I would love to know if that's useful to more people than just the announcement Twitch gives people, or just people randomly seeing me streaming on Twitch and say, oh, he's streaming, so maybe I'll watch. You most of the time when you check Twitch and notice my icon? Yeah. Okay. Well, that makes it worth it just on its own, I guess. Temple Square says, I feel like today's going to be easy, and then we get wrecked on 24 and easy on 25. 25 usually is a gimme, right? 25 is like, Merry Christmas and all that. Congratulations for making it to day 25. Twitch notifications are awful at best. I've been having an okay time with them. If anything, I get extra notifications when people have been already streaming, and then something screws up in Twitch, and then I get a second notification about it. Yeah, I guess I should be kind of afraid of tonight and tomorrow night. And then, yeah, 25 will be a gimme, hopefully. Okay, let me go back and maybe start day one. Not day one text. Let's just close everything. Eventual consistency? I suppose Discord is the best way because people can just mute everything but that channel, and then they can get a notification on it. I don't even like doing the @here at everyone, because I feel if I start using that, then people just completely mute the server, and then if I did need to let people know about something important, then they would never hear about it. What's my favorite problem till today? Oh, that's a good question. What was my favorite problem? I really like the parsing one. Was that 18? No, that was the snailfish. That one was kind of fun too. 17? No, I hated 17. 16. 16, here we go. I loved 16. I was hoping that 16 would turn into, like, there would be a part 3 on a different day. So this had to do with taking hexadecimal numbers and stripping them down to bits and then parsing it using an API, or not an API, a packet specification. You can tell I'm having fun when I just start, like, typing in, like, corny little comments for my panics. And if I'm not having a good time, I just say it's unreachable, because I don't feel like putting something snarky there. One thing we can do with cleaning this up is actually make constants for these numbers. Actually, even better would be to make an enum for it, and this packet type ID... Right, it's okay, they can't hear you. I have a special microphone here so that even if people yell in the background, you can't really hear it so well. Right, when we, like, pull these 3 bits, I could just interpret them immediately and then panic if it's not known. And then instead of using these constants 4 and 0, 1, and I don't need these unreachables anymore, right? Don't need this panic if we pre-parsed it. Looking forward to going back and finishing up those problems. Cool. As in, you skipped them, or you wanted to save them for later, or you wanted to try again with a different language, maybe? I heard something, but it didn't sound like words. Yeah, it was words, but very low and probably noise gated. Be a lot cleaner. Lots of Discords use a live stream notification role to ping. Oh, and then people can, like, through a bot, get themselves added to that. That's a good idea. Got busy with work and didn't have the time. Yeah, that's why I haven't been able to do these on time. It's not exactly work, it's the other stuff that I have to do. I always forget, is it leaderboard or stats? It's leaderboard and then personal stats. That always messes me up. So, like, on Tuesdays and Thursdays, I got other stuff during the time where the puzzles unlock. So I've just been like, sometimes I just lump them into the next day. That's what I did all these times. Other times I'll do them a little later. So that's what happened on day 20. What was it? Yeah, day 22 yesterday. Started late because I couldn't start until after the thing I was doing ended. I guess I could say what I do on Tuesdays and Thursdays. I'm in a World of Warcraft raiding guild. Casual. So it's not like we're doing, like, mythic runs or anything like that. It's just with friends. Normal projects like to check transform data as soon as possible, so something like an enum that's immediately parsed is fun. Yeah, it also make it easier to read. Hardcore gamers, not really. But Tavaros is like dominating this year. They're probably having a lot of fun because they're golfing it probably with their own language too. Yeah, so to answer the original question, I think day 16 was my favorite because I got to do parsing. I love doing parsing. But there might have been an even more fun one I don't remember. The grid pathfinding and floodfill I didn't particularly like or dislike. Didn't really think too much about that either way. It would probably be easier just to look at the days. Sonar sweep, not really. Not too. Not really that one either. The bingo one? The bingo one's was kind of fun, right? The vents. This one wasn't bad either. Lanternfish. Oh yeah, this is the first one where you couldn't brute force it because it had an enormous number there. And I figured that out on my own, right? Or I might have gotten a hint from chat. That one is up there, as in it's a good one. This one not so well. I screwed up on this one. This one was tough, and I kind of liked it that I've dealt with 7-segment LEDs before. So I have like mixed feelings about day 8 because I had to try to figure out to deduce the rules in the code, but after I did it, I got it to work, and there's some real application to that. So love it and hate it, I guess. You had fun with day 11? Okay, let me see what day 11 is in a second. This one was the floodfill one. I kind of liked that one. That was up there too. This one was like, meh. I think I had fun in that I solved this really quickly because it was an easy one. Day 11, here we go. Oh, right, the one where it flashes. I thought it was fascinating that if you go long enough, that they all synchronize. Yeah, this one, I like this one, yeah. I don't think I can say it's my favorite, but so logic puzzle, that one was fun, yeah. Wonder if that can be proved. The algorithm complexity goes brrr. Bunches in Discord took it further and looked for special grids. Or like ones where it wouldn't synchronize but oscillate between two states, maybe? I was wondering about that. Is because of the rules and how they're designed, do they always lead to synchronization, or can they lead to oscillation? This one, was I tired? Yeah, I might have said that. I kind of remember that. Oh, the paper folding one. This one was fun. It would have been more fun if I hadn't made some silly mistakes, right? And then part two was sort of weak. We could see it coming because they're forming a visual pattern. I'm like, okay, part 2 is going to have something to do with like printing it. And I think someone even said in chat, like, keep that printing code because you're going to need it. I'm like, okay. So 13, I would have liked more if part 2 was something more. 14. Okay, yeah, I said that was the first one where you couldn't brute force it. This is the pathfinding one. I would have liked this better if I hadn't made so many mistakes and if I remembered how to do Dijkstra's algorithm a little bit better. Yeah, that's the parsing one. I think that might be my favorite, but I'm weird, you know. This I didn't like, the trajectory one. if I were to pick a top 3, snailfish would be in it. I don't know if it would be number 2 or number 3. But I like this concept of numbers exploding and then splitting. And yeah, I liked it. I like this one. Hey there, Musin. Yeah, I like the parsing ones the best, I think. On the days where there's no parsing, it's sort of a letdown. Like yesterday, right? No, not yesterday. The day before, I think. There was no real parsing in this one at all, right? The input was just your starting positions. So I'm like, I could write a parsing for that, but all we need are those 2 numbers. Why can't I just type those 2 numbers manually? So that's what I ended up doing. Like day 17, part 1, because you got it by hand about 2 minutes after you start. Really? Oh, yeah. Because you're really good at the formula and the math behind that, right? It's got to be. Yeah, I can see that. Oh, where was I? Was I on 19? I kind of got off track here. 16, 17, yeah, 18, right? Snailfish, that's one of my top 3. Beacon Scanner, oh, this one was super tough, and I rage quit this one, and I need to mark my VOD some way when I export to YouTube. Like, do not watch this unless you're okay with me rage quitting at the end. I actually didn't solve this one on stream. I rage quit, stopped the stream, went to someone else's stream, and their continuation to try to solve it inspired me to give it a second shot. It was Anthony Wright's code, I think it was. And then I figured it out. And then I was happy. And then I was also sad because I did it off stream. This one I thought was funny at first. I remember thinking, we're not really enhancing. It's just a funny gimmick. I really thought it was cool that they tried to throw you for a loop by the example doesn't show it, but in most people's actual input, the boundary flashes on and off every step, and that could like lead you to get the wrong answer. And this is 2 days ago, right? Yeah, this one is also tough, but I figured it out. I think the best days are the ones that I really like it and it's a challenge and I actually figured out. That's the best combination. Hold on, I'm missing a bunch of chat. On this grid that took 58,000 steps before it synced. Ooh. But it eventually synchronized, right? I'm just wondering if they all synchronize eventually. Luckily, the math for P1 works for the inputs we were given, but it doesn't always work. You could trivially math you're talking about day 17. You could trivially math the part 1. You notice that pattern? Yeah. I think 17 was sort of a downer in many ways. It wasn't really a programming challenge. It was more like a math problem. Tainted VODs. Yeah. It's more of like a downer VOD. Like, only watch this if you want to see someone give up. I'm toying with the idea of just deleting the day 19 VOD because it doesn't show a solution. I don't know. What do you guys think? Should I delete VOD for day 19 where I never finished it on stream? Just leave it a mystery. When people ask me what happened to day 19, I'll say, you don't want to know. Between triangle numbers, it won't work. Has to be big enough as well. Okay. Very simple counterexample is 4 to 4, -2 to -2. Okay. Max initial Y speed for that is 1. Don't know. D11, since areas with equal energy levels increment spread together, their areas ever increasing in size. Okay. Yeah, you can't shoot straight up. It has to land in the target, and it slows on the x-axis. So minimally, you have to shoot really high up and have it land on the left edge, I think, right? Only solution is x speed of 4 and y speed of -2. There's no point where it works for the x positions. Because it just shoots directly and you never get high enough, right? I might be missing... I think I'm missing the grain of the conversation, but that's okay. I didn't do very well on those days anyway. It was mostly just reading what you were saying and not really getting all of it. One thing I didn't really like about yesterday was that I started using the range and range inclusive, and I don't think that it's really meant to be used the way I'm using it. It's really meant to be used as an iterator, and I didn't once use it as an iterator. I just use it as a convenient way to get the start and end, I think. Right? Even here where I'm forming another range, I'm not like needing to use any of its iteration properties. So maybe one way to clean this up is to just not use range. There's like no point. It's just makes it weird, right? It's bringing in a type we don't really need. Range contains and range start end are proper uses for it. Did I use contains at all though? Yeah, I never used contains, so I think this type I didn't need to use it. I could have just used a tuple or a struct with a start and end fields. It would have been good enough. Normally write a personal range type or tuple if you don't need it. Yeah, so yeah, that's what I'm thinking. I mean, I have time. Why don't I just do that? Then we don't need this. We'll just clean this up a bit. Struct. We'll make our own range, which just has isize, start, and end. And then range isize just becomes range. Why make it generic when it doesn't need to be? So this is probably one of the only places where we have to do something different. The other places I just need to change the types a bit and to provide a few methods. So this is range start, and we can also do away with this off by one stuff, right? We can make it inclusive, because why not, right? So yeah, is empty. Here, let's implement is empty. Is empty for some range is simply just self.start is greater than or equal to, or greater than self.end, because I'm making it inclusive now. All right. So I'm using, I could make it generic, but why? We know the type, right? This isn't not meant to be reused. I would agree that if I'm making a library for reuse, it makes perfect sense to make it generic, but the other part of me says, why put in extra characters that we don't need? I mean, you don't like semicolons, right? I could say I don't like angle brackets, so try to do it without generics. Personally, don't like the design of ranges in Rust. Yeah, it's throwing me for a loop, and also that range and range inclusive are very different from each other, when conceptually they're not. The only difference should be whether or not you include the end, right? That's the definition of standard ops range. Not being copy type makes you just like, yeah, the fact that I had to clone it. So we can make ours clone and copy, because why not? There's a phone near me making noise. Okay, we need a length. I have to be careful. So it's going to be end minus start plus 1. Self, isize. Self.end minus self.start plus 1. Right, so actually we'll make this one, which looked really odd to me, look a little cleaner, right? Start is that. End is that. And then why don't we just make a range empty? A range default or something, right? Why not? Why not? Then we can hide away the fact that there's zeros by just deriving a default. Why not? Oh, here. Start, end. And then I can just do this too. I can fold those into together. Then we get rid of some semicolons. Evil semicolons. We don't need you. You don't like lifetimes? Why don't you like lifetimes? Because they're complicated? Yeah, the range being an iterator, yeah, meh. I agree. Clone range just as cheap as a copy. Then it shouldn't be... It should implement copy trait. That's my opinion. If it's cheap, then mark it as copy. Range being an iterator is why it's not copy? Why can't you copy an iterator? It would be confusing to a lot of people if it's copy. How so, Musin? You must got your JVM to print hole. Oh, nice. Yeah, Musin was working on a JavaScript virtual machine, right? In Rust with no semicolons. Sounds like a good time. It shouldn't implement copy. Why not? Moving an iterator wouldn't invalidate it, and you get partial iteration. What's the problem with that? I'm still hoping to learn from you what the trap or downside or penalty or cost would be for partial iteration or making an iterator copy. You'd copy the state of the iterator. But what's wrong with that? You could do start to end and then step it twice, and then copies will not get the first two values. Well, that's because we're conflating the concepts of a range and an iterator. Shouldn't a range just be immutable? And then when you iterate that range, you should get a different type, which is an iterator of a range? Conceptually, that makes sense to me. Here's a range, 1 to 5. Here's a range iterator. It's something that's pointing, if we expand this, 1, 2, 3, 4, 5, it's something that's pointing to one of these. Little hat there. Right? Range iterator could borrow the range to make sure that it's immutable, and it should point to something in there, but these should be these are different things conceptually. That's my opinion. Again, not true in Rust, but what I would have done if I had invented it. But then again, there's probably a downside to this I just don't understand yet. If range was copied, the value there would still be 0 to 10. It wouldn't invalidate the iterator. So my solution, separate types. Make this one copy. Why not make this one copy too? What's the danger? You're just duplicating a reference. It's an immutable reference anyway. I don't know. Sometimes I get in this mood where I get really opinionated. And I don't mean to offend anybody, but that kind of opinion comes from a misunderstanding and misperception of what Rust is versus what my intuition says it ought to be. It should have been a range iter, but that was a 1.0 choice. Yeah, so that's the price of making a standard, right? Is that you're kind of stuck with it now. So what it ends up being is it ends up being a footnote or a special page that you attach to the manual somewhere saying, this is the chapter of non-intuitive mistakes made when the standard was made. Like usually in a standard like on ITU or ISO, they make something called a annex, right? A informative or non-normative section of the standard that kind of explains what the heck they were thinking when they made it. Iterator types are copied to prevent confusion, issues with multiple iteration and copying state. So yeah, I agree with you guys that if you don't make range and range editor separate types, but you conflate them, then yeah, it would get really confusing if you took something that you thought was a immutable range, started iterating it, and now you're actually moving the range around. That would be really confusing. It's literally the exact same code as the copy for a range. In fact, we could make our own type that we could make this wrap the real range, right? I could do this. Standard ops range, is that what it is? And I could implement our range in terms of that range, and then I could make it copy, and then I could make the implementation of iterator make a different type that wraps the same range, but maybe a clone of it. Like, yeah, we could do that. I don't see the point of it, but... Oh, was I done with that? Is that all we needed? Let's run the test to make sure I didn't break it. I love unit tests because I can just run them, and if they work... Okay, they didn't, so I messed up. Oh, probably because I changed the inclusivity of the end. So I gotta look through this pretty carefully to look for that. It's not that, but I just wrote that. It's probably in here where I added one, right? I actually don't need this anymore. That was another weird thing about using standard ops range, that I needed to put a turbofish there. Okay, I'm not seeing it. Is it in the intersect? Oh, it must be here, right? I think it's here. I think these need to be that. I think. I'm not sure. I'm just guessing. I don't want to think too much about it. Nope. Wow. What is that? Linking failed. I haven't gotten that in a long time. Oh, is it because it's still running? Okay, yeah. The part 2 was still running from before, so we couldn't relink it. Nope. It has something to do with this, right? 2 ranges intersecting. It's a left start. It's before the end. So what if it's right on the end? Yeah, that should be less than or equal to. And the other one, if the left side end... That should also be that, shouldn't it? Then they intersect because it's all inclusive. That's how C++ does with the copy? Okay, we're still talking about copying and cloning and stuff like that, right? I was hoping that someone would have spotted an error that I made. Pretty sure that there's an error in here, some assumption about the end being inclusive versus exclusive. Oh, maybe it had to do with empty. Yeah, because the default range 0, 0 is not empty. So let's not do the default. Let's actually make some special method there. Empty. And we'll just make one that's arbitrary. Like this, right? This is probably it. And it doesn't go in cuboid, does it? It goes in range. We'll just say like start is 1 and end is 0. That's definitely empty, right? Okay, let's try that. I don't like that though. Maybe I should make it an option inside. I think I will. I'm gonna make this an option. You can't do that though. So what's the next best thing? Have another struct? Make... Oh, I know what I can do. Will this make it too complicated? We can make this an enum. And we can say empty and non-empty. Is that going to be too gross? So this would just be self-empty. I love playing around with Rust types because you know when you did it right when your red squigglies go away, and it's sort of like a game. Stomp all the red squigglies, right? So this is range non-empty. Yeah, that's not too bad. And it's actually very descriptive. It's a non-empty range. It starts and ends there. So is empty is simply if let range empty equals self true. Actually, then here's where Musin usually jumps in really quickly and corrects and gives me something better. There's probably a way to do this without the if else and the literal true and false, right? Matches, there it is. Thank you, Musin. Here's some meaningless internet points for you. Yes, matches. I don't give matches enough credit. So, yeah, self. Yep. I don't think I've used in matches enough to commit that to memory. So, length, I think we'll just do a match self. And if we say, oh, here's another opinion poll. Would you viewers prefer self here or range here? I'm starting to think self is better because we only have one point where we would need to rename. But, like, it is a symbol we can only use inside of the impl, though. Outside of it, we can't use that. So one could argue that range there as well is better. I'm on the fence between those two. Like, it actually feels better to have range there, but self only when we're producing self. I don't know. I'm really on the fence between this one. Isn't it unstable and also arbitrary? Oh, you're talking about standard mem discriminant, if you want. Self-loss for easier refactoring. But does it? Because when I refactor, I just highlight it and hit F2, and it renames it everywhere. Right? So it's all the refactoring is already pretty easy. Sometimes if there's a lot, you use self everything. You remember when self partially existed and before that didn't exist? Partially existed? So you mean this is added to the language in pieces? Remember when Rust Analyzer wasn't a thing? Oh, the good old days when our tools were made out of bronze. I got about 5 minutes left. That use statement locally imports all the variant names without needing a prefix. Oh, I see. Well, in this case, it's not descriptive enough, right? Empty, non-empty. Empty what? Non-empty what? Oh, range. What was I getting at here? I want to just say 0 there. Range, non-empty, start, and... Oh, this actually allows me to get rid of that self keyword. I can just say start minus n plus 1. It's too bad it won't fit all in one line. And I can't make it, right? If I try to make this, I think it's my own rules. My own rules prevent that from keeping it one line. All right, following the red squigglies. Okay, this gets a little bit more gross, right? Because we have to have 2 matches. Why type when I can let fill match arms do my work for me? Actually, we already know that this is going to be empty. But for non-empty, we're going to have to do another match on the right-hand side. And then that goes there. Actually, what would be better is to just do match on both of them at the same time. Right? Because then we can capture the empty, or actually the empty anything, right? Or the anything empty goes to empty. Then the only alternative left is the non-empty non-empty. Like that. And what was the syntax for naming it something different? Was it like left start at? Or was it start at left start? Is that how it's done? Can never remember that. Fouet bar, but which one's on the left and which one's on the right though? It's not going to be helping me out very well because I have to, well, I can comment that out for now and say it's to do. I've gotten into this habit big time of commenting out code that gets in the way and doing it to do's just to focus on one bit of context. What's mismatched? Oh, because I haven't returned anything? What if we just return range empty for now? It really doesn't like me. Why does it want to okay, do I just do that? Yeah, I don't need it to do. What am I thinking? So I must have got that backwards, right? Left start. Sometimes it's easier to just try it one way and then, oh, no, maybe it's not easy. What's its problem? It needs a comma. It's name field. Name, so new name field. So the add is used in tuples or something like that, right? Pattern does not mention field start. Do I have that backwards then? Okay, maybe it might be confused because there are there's duplication here. I have a feeling that I have this backwards. I think it is backwards. It's like that, right? That feels more correct. Yeah, I think, yeah. See, you can see my style sometimes. I don't bother to just figure it out, like, by reading the book or looking up the rule. I just try it one way. If it doesn't work, you just try the other way. That's just something that lazy engineers do after a while. Right? If there are only two possibilities, are you really going to thumb through the manual to try to find which one it is? Or are you just going to try one, and if it doesn't work, you try the other one? Oh yeah, we have 1 minute? Okay. I need to at least make this compile, or I have to stash it. I think I'm just going to end up stashing it. Let's stage all these and stash this one. Stash, not stage. Don't need a message. Just do it. All right. We got 30 seconds. So what is Advent the code? If you haven't figured it out by now, it's an Advent calendar of programming challenges. You get a 2-part puzzle every day from December 1st to 25th. There are corny Christmas themes. So this year we've dropped the keys to Santa's sleigh into the ocean, and we have to get in a submarine all the way to the bottom of the sea to fetch it to save Christmas. So you can program it in any language. So if you're doing this with me, good luck. If you can do it really fast, you can get some points. Don't expect me to get any points. I'm going to pick Rust again this year. Maybe next year we'll try something different, but here we go. How do you say that? Amphipod? A group of amphipods notice your fancy submarine and flag you down. With such an impressive shell, one amphipod says, surely you can help us with a question that has stumped our best scientists. They go on to explain that a group of timid, stubborn amphipods live in a nearby burrow. 4 types of amphipods live there: amber, bronze, copper, desert. They live in a burrow that consists of a hallway and 4 side rooms. The side rooms are initially full of amphipods, and the hallway is initially empty. They give you a diagram of the situation, including locations of each amphipod, each of which is occupying an otherwise open space, walls, and an open space. The amphipods would like a method to organize every amphipod into side rooms so that each side room contains one type of amphipod, and the types are sorted A through D, going left to right, like that. Is this like the Tower of Babel? Good luck, have fun. That's right. I'm only going to be glancing at chat here now and then, but I won't be able to engage while I'm working on the puzzle. Sorry about that. They can move up, down, left, and right so long as they are moving into an unoccupied open space. Each type of amphipod requires a different amount of energy to move one step. Amber amphipods require 1, bronze 10, copper 100, and desert 1,000. Amphipods would like you to find a way to organize amphipods that requires the least total energy. This is the Tower of Babel problem, right? Which means we want to have the A's move first, B's second, C's third, and D's last of all. I think, right? However, because they are timid and stubborn, amphipods have some extra rules. They will never stop on a space immediately outside any room. They can move into that space so long as they immediately continue moving. Specifically refers to the 4 open spaces in the hallway that are directly above the starting position. Amphipods will never move from the hallway into a room unless that room is their destination room. And that room contains no amphipods, which do not also have that room as their own destination. If amphipod's starting room is not its destination, it can stay in that room until it leaves the room. For example, an amber will not move from the hallway into the right rooms and will only move into the leftmost room if that room is empty, or if it does not, or if it only contains other Yeah, so this is Tower of Babel, I'm pretty sure, right? Or Tower of Hanoi. That game Tower of Hanoi, right? Towers of Hanoi. You know what I'm talking about? This game. Where you have like you have a whole bunch of discs and you have to move them to a destination, but you can only move them one at a time, and they have to go on like a larger one can't go on a smaller one, so it ends up being basically counting in binary until they all get to the destination, right? It's that kind of problem, I think. It's what it feels like. Once it stops in the hallway, it would stay in that spot until it can move into a room. Yeah, exactly. So these 2 hallways essentially are the temporary like registers, and these are the memory locations, right? So you can move it, load from memory into one of the 2 registers, and then, okay. The amphipods can be organized using a minimum of 12,521. When I do this is shown below. So, like I've been doing every day, we're going to take, I can close this now. I can take the number that they gave us an example and say that that's the answer given the initial input. I guess it's that. Let me look at my real input to see what the format is. Okay, so it does have spaces in there for us. That's nice. So, save. Okay, so I'll format it the same way. Although this is going to have a whole bunch of extra spaces, and when we trim, it's going to smash these rooms off like that. I had to be careful about that. I think what I'll do is augment this a little bit. I'm trying to think. Something that like will trim, then eat the left character and trim again, if the left character is a special thing, but that's going to be different from our input. The input is so easy. What if I just simplify my parsing? That's our input, really. What if we just have like A, C, D, D, C, B, A, B, and that's our actual input, right? Can't I just do that? Why bother parsing that other junk? A, C, D, D, C, B, A, B. There, I've reduced the problem a little bit. Do the same thing here. B, A, C, D, B, C, D, A. Why not, right? You point to input, test input file, that works, yeah. Yeah, I was thinking like, why bother doing a bunch of parsing that, I mean, normally I love parsing, but that seemed just stupid. I don't know. That's the information we really need. Everything else is constant, right? The dimensions are constant. We could just make constants for that. Anyway, what's their example? Show me. We start there. One bronze moves out. Because I'm going to assume it's like Towers of Hanoi, where the first one to move should be the lowest energy one. So one of those Bs. But which one? I'm not sure. They say one way, so maybe there's multiple ways. We could always just do it with brute force. Taking 2 steps and using 4 energy. 40. 1, 2, 3, 4. The only copper one not inside moves there. Also, there's more places it can stop, right? Wait, what? Oh yeah, it hangs out in the hallway. Okay, so we have like we have two places they can move that are 2 deep, and they can also move into the spots between rooms, of which there are 3. Okay, so maybe like with a couple buckets. So we have left bucket, right bucket, and then of depth 2, and then we have 3 mid buckets between A, B, BC, and CD. Yeah, hope that part 2 will not make me parse. Well, then we'll do the parsing. We'll do it when we need to. So it moves just 4 spaces out, and that clears the way for C to move in there, which costs 400. Then the desert one moves out of the way. Why does it? Oh, this one out, right? It's to clear the way so that the B can go in there. Then the leftmost one moves to its room. Then the ones from the rightmost room move out of the way. The D moves to the left. The A moves out. Then the D's move in. Finally, the A moves back over. Okay. I feel like I want to just brute force this, because there aren't going to be that many possibilities. So what are the possibilities here? B can... I wonder if we'll ever need to use the left and right hallways. Yes, we will. And did it mention about the side hallways at all? They only said that it'll be a room, right? So can we occupy both steps in the hallway? I think the answer is yes. That's a possibility we have to consider. And they don't have to be the same type either, right? There's no rule against that. The only rules is that they'll never stop immediately outside a room. They'll never move from the hallway into a room unless it's their destination, and there are no ones that are shouldn't be there. I'm reading this part here. Once we move into the hallway, it has to stay there until it goes to a room. They're locked in place. Okay. That's just limiting the possible paths that we have to think about. Okay, so what are the possibilities? B could move to the very end, could move one right to the end. It can move to that hallway, that hallway, that hallway. So there are basically 1, 2, 3, 4, 5, 6, 7 possibilities. Same thing for C, same thing for all of them, right? And I suppose we could optimize it to like favor these 2 first, right? And in this case it moves there. So in this particular arm, we're picking it because it's not in the Actually, it should move if it's not in the right room, or the one below it is not in the right room. Okay, yeah, these rules are going to be kind of complicated. Anyway, this one has 2 possible moves. This one can't move at all. This one has 1, 2, 3, 4, 5 possible moves, and it should prefer this one because it's a finishing move. Okay, that tells me that whenever we're considering something to move, we should first see that if it can move to its final destination. If so, it should just take it, right? So that's what that does. That one is clearer. So after this, the next one move again. The B could move out. This B could move. No, we don't want to have it move back in. It can move 1, 2, 3, 4 possibilities, or the D could move to 1, 2, 3, 4. No, it doesn't. It sees. No, sorry. It could move out to 1, 2, 3, 4 possible positions, or this one can move out to 1, 2, 3, 4 possible positions. In this case, it picked moving to there. I guess every step we go, we should see, can any of them move to their final rooms? So we should keep track of which ones aren't in their final rooms. Or maybe that's just a premature optimization. So, yeah. This one moves to its final room. And then we end up choosing the path where D moves out. And then A moves out, and then D goes in. The other D goes in, and then the A goes in. Okay, I think I see how this would work. Do I want to process this even more? I mean, I could. I could say that this is oh, that didn't work. Oh, my cursors aren't right. Close that. All right, I can do that. An array of 4 arrays of 2. Like that. And then I don't even need a 23 text. I just know what it is. Delete. Where's my delete? There it is. Delete. Delete, I said. Not rename. Delete. You are deleted. Const. Oh, we already have input. It's one of these. Equals that. Let's process it. There we go. Okay. And let's just fill in this there for now. There we go. All right. So let me think about this. We should have some concept of like available rooms or something. Available intermediate spots. So enum temp spot. left 0, left 1, AB, BC, CD, right 1, right 0. Let me flip those around. I'm just conceptually going left to right and just naming them. And then in here, I guess we'll have temp spots. Let's make it mutable. Hash set new. And insert all of them to begin with. Temp spots, insert temp spot left 1. Let's see if I regret this later. To do at the end, right? Import that hash set. Okay. What does it not like about this? Oh, these need to be... We need code generator for this, so like equal hash partial equal. Okay. And I think we want to repeat until we get a certain configuration, right? Let's, instead of calling this input, let's call this state. And we'll say while state is not equal to A, B, C, D. I can't do that. Variables in the condition are not mutated in loop body. Okay. Really?
Let's go.
I just want to check that my syntax is good. How about we like chill on that for a while, Clippy? Yeah, okay. We'll remove that when we're done. I think I want to have an inner loop, like, that's recursive. So then instead of really having this while, it's, that's just an innermost check to see if we've solved it, then we return back up the total cost. So let's move that to something like solve state 0 for initial cost and temp spots sports to string function solve. This should also be mutable. So I could just take this actually. Actually, we can't do that. I need to have storage for it, right? Also, actually no, that can be constant. This can be constant. I don't need, yeah, that's fine. That's fine. We can do that. It just needs to be mutable. It's an owned array, right? Yeah, okay, this will work. So that, and then we have a temp spots. Why do I keep wanting to type sports? Not really into sports. Why am I typing it? Hash set of temp spots. And then a, they call it fuel, right? Or energy. Okay. And I want to dereference that, but really that's not what I want. Hold on. Let's just comment that out for a moment. That's my end state, right? We want to first look for, can we move something to its final destination? So let me maybe break that off as another function. And we want to do that for every temp, well, it doesn't matter. It can do the temp spots first. No, this is the wrong kind of structure for this. This needs to be a map. Because we had to track what's in there. Let's put a none in there for now. Can I just put in the type for now? Temp spot and option care. Actually, I'll need that type here. This is the kind of sport that's true. These shouldn't just be cares either. I mean, I could use space. Maybe that's better than using an option care. We'll just use space for empty. And then instead of none, it's just spaces. Okay. We're basically here looking for what's the next move we can make, or what are the different moves we can make, and for each one, see what the energy would be to solve from that point on, right? And then picking they wanted the minimum. So
I did, but I don't have that character anymore.
first I need to get basically a list of all the possible moves. So let mute moves equal vec new. And then, yeah, we'll just go through the state to see are there any amphipods in the state, and can they move to their destination? Actually, if we find one that can move to its destination, then we immediately get an energy from that we add to our list. We don't need to recurse. No, that's not true. Right. Okay. There's a move we can make, and then if it's not the end state, then we have to recurse and try all the rest of the moves in that. But we can. I'll just do it without the optimization to begin with. We'll just find all the possible moves. So for C in state, well, for row in state. What are they calling this? Not a state. Burrow. And those aren't rows, there are rooms. So for room in burrow. And then if, I guess we first check the outermost. So the second one, if room 1 is not equal to space. Else if room 0 is not equal to space. I'll just put to-dos to fill in the things that we need to do. These are all like trying different moves, right? So then after that, we're going to try all of the temp spots. Should I call temp spot like hallways? Let's do that. Let's call temp spot hallway. Temp spots is hallways. F2, hallways. There. All right, for hallway, in hallways, if I have to be careful here, though. For these hallways, oh, actually, we can just have rules that like left 1 can't move if left 0 is occupied. But if left 0 is not occupied, it could move into room 0. And it can move into room 1 if nothing's in AB. It can move in room 2 if nothing's in BC. It can move in room 3 if there's something in CD. It can move into... Yeah, so there's just certain rules that we can say. If hallway is not equal to that. So I'll just have a function that figures out if you can move from one to another based off of what are in the rooms and hallways. So this, I need to give names for these things. Hallway and, what are we calling this? Name. Thing in hallway? Occupant? To dereference that, I guess. Okay. I guess I could put this at the very beginning. Might as well, right? If state is equal to that, then return energy. Right? It's burrow. Because then we don't need any further moves. Otherwise, these are all going to return... Well, these are going to add to a list of moves. So at the very end, it's going to be... Oh, how do we signal that there are no possible moves? That they can get stuck. Okay, so we should make this an option. Because it's possible that we get stuck. That there's no possible solution. Right? So basically, if there are no possible moves... Moves is empty. Oh, actually, I can do this with max, right? Min? We want the min. Moves into iter, min. Actually, that's all I need. Right? So if there are no moves, we return none. If there's some move, we're going to take the minimum of that and return that as the energy. Right? That it takes to move, to get them all in the right position from that spot. I just thought of something. I need to be careful. Oh no, I don't really need to be careful about them going back and forth. Oh, no, I do need to be careful. I can get into a position where they keep... Oh no, that's okay. I keep going back and forth. Sorry. I was thinking, is there possible that we get into an infinite loop? But I think they designed the rules such that we don't get into an infinite loop ever, because if it's in a hallway, it'll only move to its final room. If it's in a room, it'll only move to its final room or a hallway. So that prevents us from getting into any kind of infinite loop. So we can just make this in all of these positions, right? Well, hold on. Let me be careful about this. Let's do it for one. If can... Or can I just enumerate all of the places they can move? And we can also, while we're doing it, just compute the energies as well. For... What are we thinking? Destination? Oh, hold on. Maybe I need to include that here. So maybe hallway needs to be expanded to rooms as well. Hallways are rooms? Actually, then maybe this maybe I absorb that into the overall state. That would be simplest. So hallway are like positions. And these are all hallways. I'll just do it here too. So this is really positions. This is a position. And I should, yeah. I'll just encode it right here. Room A1, room A0. Actually, let's just put them in the correct order then. Although it doesn't really matter. It'll help someone reading it figure out what I'm doing. Depth first, in order. So this is C0, C1. So these are all the possible places that these amphipods can go to. So yeah, then I need a whole bunch more inserts, right? So we got room. And okay, I have to be really careful here. Which order did I do them in? I did 0 and then 1, right? Okay. Double check my input. AC, right? AC. AC, right? So that's what I wanted to be the outermost first. So that's A0 is burrow 0, 0. A1 is 0, 1. I got it backwards. Because I wanted A to be the outermost one. The one that's listed first. Yeah. Okay. And I should move those to here. Right? Because here's the B rooms. And here are the C rooms. And here are the D rooms. Okay, so we're solving positions. Yeah, so I don't need, there's no hallways. This is just positions. And this should do an unwrap because there needs to be at least one solution. Oh. Yeah. How to detect this? Well, I guess we'll make this another function. I guess I can just construct the solution. Can I? No, I can't do that. I guess we'll just have it have a solution. That's just borrowed. And then we'll construct it here. Oh, we can shorten this a bit. Yeah, we can just say let mute solution equal that, and then I only really need 4 inserts, or yeah, 8 inserts. We don't actually need to list the hallways at all. And instead of doing new, what I should have done is positions.clone. I actually don't need to do an insert because we know that we can index them, right? Need to make this clonable. Might as well make it copyable while we're at it. Yeah, okay, fine. You can borrow. here's the solution. A, B, B, C, C, D, D, right? Solution. All right, kind of messy, but then this becomes if positions equals solution. For, yeah, these collapse together, right? For position, actually it's this one right here. For position and occupant in positions. If the occupant is not empty, then I mean, I guess here we could write it in place, the code to check to see if there's a path. So I can envision a function which goes towards the destination. So, well, wait a minute. There's two functions. There's a function that is going to give us all of the possible places you can move, and another one that actually it's the same one.
Oh boy, I can't wait to wait for.
Let me think about this. What didn't it like about this? Kind of index.
Entity spawn rate.
Is it because I didn't mark this? I did mark it as mutable. Oh, you can't do that? Do I have to do insert?
There's no range.
Okay, fine. Insert it is. Fine. Insert it is.
Build it instantly.
Should make this easy. I should just say
I don't think I can kill it.
let
Not to
destination energy, well, more energy equal, well, hold on, let me think about this. That is going to be for in moves. Well, I already have something called moves. Possible moves? Let possible moves equal find possible moves for given the positions and the current position and occupant.
what's happening.
Okay. So in this, it's going to be if let some total energy or move energy. Let's not call this more energy. I'll call it additional. Oh no, it is move energy, right? If some total energy should I just have it do the add for me? Then I can just say push onto moves.
A lot of these dark.
Ultimately, I want to call solve with positions Oh, I just thought of something. This is gonna be expensive because I'm gonna have to clone the positions. So that means this doesn't need to be mutable. It can just own it because we'll have to clone it anyway. That's okay. We're doing brute force, right? So then that means I have new positions. I don't even need a destination then. Solve new positions. Solution. Energy plus move energy. If let sum. Total energy, move energy, total energy equal that, then moves push total energy. Okay, what didn't it like? Oh, yeah, we own it. And this dereference. And, okay. So now we just need to write this function called find possible moves. So envisioning that we have a function find possible moves that gives me a collection of tuples of what the burrows would look like and how much energy it would cost to make that transition, then we would say, well, can we find what's the minimum solution from that point? If there is some, then that's the total energy it takes, and we're going to minimize it and return that back out, right? So I just need a function here. Okay, this returns the new position, so one of these back out. And U size. And it's a vector of those. First, just to be simplistic, why doesn't it let me type that character? We don't need the... Oh, do I need the... I do need the position. I don't want the solution there. So position. And we need occupant, not energy. Oh, this has to borrow that. No? Hold on. Borrow it? No, it got moved. Okay, so we need to borrow that. And then dereference in a couple places. Dereference. Yeah, we'll have to take this and make a new one based off of the moves that we make. Okay. So we're given a position and an occupant, and we're saying, like, what are the possible moves? So I guess we'll just do a match on that occupant first. Anything else and it's unreachable. B, C, and D. Think about it spatially, it's hard. From any one position, there's up to, well, I could just encode all of these possible moves, right? From here, we can move to any of the end rooms that are unoccupied. Actually, that's not true. there's if we're there and we should move to there if we can, otherwise there if it's an A, there if we can, otherwise there if it's a B, etc. And then we have a list of intermediate rooms that have to all be clear, right? So is that yet another data structure that I need? I think so. So in A, we should try to move to its final room first. If you can't move there if this one is an A. If we can't move either place, then consider moving to to any of the accessible hallways, but only if it's not already in a hallway. Oh, the other thing is we should not move it if it's in its final position. So not just this, but it should also not move if it's in a final position. So if occupant is not and not final position occupant, right? Oh, and okay, it's even given this example, right? Where is an example of this? This D is in a final position, only there's an A below it, so there's extra rules to consider. So that means I need to also have the positions.
Wait, not yet.
Positions, occupant. So it's actually the same as finding the possible moves. In fact, it's a lot of the same thing, right? So this one would be position equals position room A0, which is the deeper room, or room A1 and position or get, actually, I guess matches position room A0 as a another A. What? Oh, sum A. Whoa. There we go. And then B, C, and D are all similar, only different rooms. So B's want to go to room B. C's want to go to room C. And go with another C. And D's want to go to D. Am I making this way overly complicated? Perhaps. So we're only considering the ones that like still need to move. Then, and this is the condition if they still need to move, if they're not in their final position. And I need to make sure I don't mix those up. A0, it's depth first, right? And then breadth first. So this is the deepest hallway left. That's the deepest room, A. If it's already there, it's fine no matter what's in the other position. If it only moves to the outer one if the one in the inner one is already correct. Okay, I got it. Then we'll also use final position to see if it is a final position, right? Because Actually, I don't even need this match, right? If it's
Wait, that one took 2.
in a room, it wants to move to a hallway. And if it's in a hallway, it wants to move to a final position. Right? So, can I just do a dumb, like, loop through this? Just have, like, an array here. So, like, for destination in this entire list.
Not a rabbit.
And then I gotta put position in front of all these. And then I'll say, actually I could do this in 2 steps, right? It would be helpful if I had a function called isHallway. So let's invent one. If position hallway then yeah, actually I might not need this one at all. If position is hallway, then there are 2 possible places that it wants to move to. Depending on its letter, though. So I bet someone's solved this in 2 minutes, and I'm almost to an hour. Yeah, so we'll just say for I don't know what to say here. I guess I can have another constant. I really want to have like something I can look up. Given an occupant, I can list like the positions to try. We'll just do a match on occupant then. I had that down here. If it's A, then if position room A0, if final position, positions, room A0, occupant A. It should prefer to move to that position, right? Else there. Then we should try here, right? Oh, then I don't need an else if. Because if we find something early, then we're going to hold on, let me think about this. If it can move there, it doesn't need to consider there. Yeah, these are going to be early returns, I think. If it can't, then down here it would return vec. Well, we can construct it up here. Let mute moves vec new. Just return moves here. Actually, another way to think about it is there's an else. And return moves there. Okay. Can delete all this stuff. What to fill in here, though? We just say if let some energy equal is route clear. Given the positions, and given the position and the destination, which would be here. Then moves, push, energy. Actually, it's a bunch of things, right? It's... What if I just have it produce it here? New positions. And the energy, yeah. Then I don't even need this to be in the tuple. So new positions and energy. Do that way. And then we'll put that here. It's gonna be a lot of copy paste, unfortunately. This one needs to go go to room A1. Oh, I also need to know the occupant because that changes the amount of energy. Oh boy, this is gonna be a long function. So for B, we want to go to B1. Yeah, this is going to be a good candidate for refactoring later. Actually, what if I just put occupant here? That'll make it easier to refactor later. There are fewer things that are different between these. And I'm not collapsing these two functions together yet because I'm thinking I'm going to reuse final position if I haven't already. Rewrite this. Whoops. Rewrite that to be C and C. Oh. Copy paste bug. There we go. B. BS. A001A1, B0B0. I should make a small function that does this for me. I'll do that when I clean up. I need to have something to do after I get the answers to today's problems, right? So right now I'll just copy paste and I'll clean it up later. Yay! Okay. So that handles, as long as I write this function route clear and hallway, that handles moving to the destination. But how do we pick which hallways we move to? I think I'm just going to pick them all. So for position in do, and this is going to be all the hallway positions that we could possibly move to. And we'll just say, is the route clear? If we can, consider that position as a possible move. So all these minus the final rooms. There we go. So considering all of these positions, this code basically, if some new positions and energy equals route clear to that position given this occupant, and what do I have an extra variable in there? Oh, that's where we're going to. This is new position or hallway there. Then we would add that. So in a sense, if we're in a hallway, we're only going to have one possible move that we might try, or we might have zero if we can't move there. But if we're in a room and we're not in our final destination, then there are various hallways to consider, and we just try them all. Have all these possible moves. So now I've reduced the problem to I need to define what hallway is, and I need route clear. So hallway's easy. We'll do that now. Implement position. Function hallway given a reference to self. Matches self position hallway left 1 or hallway left 0, or hallway AB, or hallway BC, or hallway CD, or hallway right 0, or hallway right 1. Right, those are all the hallways. Okay, and then I just need a route clear. Function route clear. Produces new positions and an energy, right? Optionally. Or ugly type. Okay, what does route clear need? It needs positions, it needs a bunch of stuff. Okay, positions is a borrowed of that, right? Position is a this is start position. This is occupant as a character, and then this one is the destination. There we go. Okay. We can do this. So should I just hand code this based off of a big match? Yeah, well, we'll hand code this. Actually, I can just do it with a big match, right? Match. Destination, right? No, we want to match start and destination. There's going to be a lot of combinations. Ready? Here they are. Some of these don't make sense, though. We would never go from between two hallways. So every time we have two hallways, I delete it. Right? Easy enough. Delete all the hallway to hallway transitions. We never move from the same, like room A to room A. We do consider all those other ones, though. Or just remove that one. Okay, remove hallway to hallway transitions. Remove the B to B and the other B to B. Okay, and then remove hallway to hallways. Remove C to C. Doesn't make sense. Remove hallway to hallways again. There are probably other ones in here that don't make sense either. And remove D to D transitions. And again, remove hallway to hallways. Okay, which ones here that are remaining don't make sense? And we should, to make it compile, I should have a blank here. Is empty array. Because what I want to do with this is say for move really in this. What we're going to do is we'll say if it's occupied, then we're returning none immediately. So if positions dot is no, we do a get, right? And we just look for a space character. So then can I just do this move? Can't use the word move. How about step? Is not equal to space. Then return none. Otherwise, we want to, we're going to have a running count of the number of steps, I think. Right? Well, we can just say let energy equal 0. At the end, we're returning basically a copy of positions, but with the occupant moved out of its starting position and moved into its destination. So I guess we'll do it down here. Some new positions and the energy. So we got to compute that new positions. Let mute new positions equal positions clone. This is ugly. I hate doing this. New positions. Insert start blank. New positions. Insert destination occupant. And yeah, that. Okay. If it is unoccupied, then we match on the occupant to say energy plus equal, depending on the occupant. It's the whatever rules they gave us. It's like 1, 10, 100, and 1,000, I think. Or did they say that? 1,000. Here it is. Yeah, A is 1, B is 10, C is 100, D is 1,000. That's unreachable. Okay. This is crazy. Oh, this is just moves. Let's fix the warnings as we go. This didn't need to be mutable because we just owned it and moved it into positions. What else? Don't need hash set anymore. Okay, that's fine. We haven't implemented that. Okay. So in these ones, basically, I have to hand code. I have to either remove it or hand code the array of intermediate steps and destination steps. So, yeah, these don't make sense. Left to A1 is left 1 to A1 is, yeah, that's left 0 A1. No, and it has to go to I have to add an extra energy for the intermediate step, actually. So let's just say it moves twice. So hallway, I keep confusing my zeros and ones. So 1 is deepest, right? Because our input was, no, okay, I have this wrong. Oh no, I reversed these, right. So 1 is deepest. That goes to 0. 0, right? I hate having to double check my work like this. Where is it? Where's part 1? My functions are all over the place. Not good. Here it is. Let's fix that. Let's put this with part 2 so that I don't get confused about where things go. There. 0, 0 went to room 1. Okay, I don't like this. I'm getting room A1 and A0 confused. I think I wanted 1 to be the deepest. If it's AC, that's 0, 0. Yeah, I have this backwards, I think. Like, before I change that, what was the rule about final position? 0 is the deepest. Okay, I got it confused then. So, to be consistent, shouldn't the hallways be the deepest, 0 be the deepest hallway? Yeah, that's how I'm getting myself confused. If 0 is the deepest and 1 is the outermost, then going from deepest out and then into room A1 and then down into A0 and then hallway A, although alternative path is that. Alternative path. Yeah, okay, that makes more sense to me. Hey there, Endor. You had something backwards? You had hello backwards. You did. Welcome.
Oh, 184.
Hallways are easy. Those deepest rooms are always final positions. Non-deepest rooms are... Okay, did I get that wrong again? Yes. Deepest room, outermost room. Outermost room is only final position if the deepest room already has its brother in it, basically. Find possible moves. Okay. We tried the deepest room first. Then tried the outer room. Correct. Okay, and then route clear. So, to go from 1 to outermost room, we go to the hallway and then we'll count the room twice because it actually takes 2 steps to get there. Right? If I look at this, if we're here, it's going to take 1, 2 steps. 3 actually. 1, 2, 3. So we're here, 1, and I'm counting the final, that room twice. We never stop on these squares, so we just basically need to count it twice. Okay, and then we just do this again for all the other positions. So this is an extra step to A0, right? What's wrong with this? Oh, shoot. These have different sizes. Oh, crap. This is going to be ugly, but we'll just make them vectors. Vectors didn't have different sizes. It's just going to allocate memory every time we do this. Oh, this sucks. Oh, well. Yeah. Well, that's fine. This is fine. We're not on fire. We're definitely not on fire. Okay, anyway. Hallway left. This has to go to position hallway AB, right? Twice. So left 0, which is there, then 2 steps to get to the hallway between AB, and then 2 more steps to get into room B1. Okay. This one requires an extra step to 0. And then this one, we put BC twice. Then to C. And then add position room C0 at the end. Let's do this one first. CD, CD, D, 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 because that goes here with an extra bracket without that one. Okay. So these are all copies of these without that extra step. So I'm just going to take all of these. Copy pasta. And turn hallway left 1 into hallway left. Oops. Dang it. Hallway left 1. Select all of them here. And turn them all to hallway left 0s. And then just remove that step there. This is tedious. I sometimes get into this trap where I end up going a tedious route because I just don't bother to think of an easier way. But it'll be quite fast, except for this darn memory allocation we have to do. I think think a better way would be to encode this all once. So that'd be an improvement that we do. Encoding all the routes, right? Okay, now to go... Okay, these are the more interesting ones. Let's just change all these to-dos right now. There are quite a few of them, aren't there? There are quite a few of them. Change them all to empty vectors, all right? Okay. This actually moves straight to the destination in 2 steps, doesn't it? A1 to hallway, left one goes blip, blip. There. Okay, and then this one has an extra step in it. That's zero. Excuse me. Oh, we never moved. Oh, no, we do. Sorry. That's also 2 steps. Okay, and then, yeah, then to get to B, we have to move to that hallway, and then into room B1 in 2 steps. Okay, and then to go to B0, it's an extra step into B0. Then, yeah, these get a little bit repetitive, don't they? C0 is like going to B0, only it's C's, and there's an extra hallway we have to traverse. The BC hallway. And then that's like that, only there's no C0. How far am I into this? I'm not that far at all. This is gonna be nuts. Maybe I should stop. Maybe this is just a horrible way to do it. Yeah, it's just hallway BC twice, right? This is nuts. It's crazy. What am I doing? What are you doing? CD. We're almost done with the A1. Now I gotta do A0, which will be a copy of A1 with an extra step. I'm actually thinking, rather than doing pre-computing this, we just treat this as a graph, and we just do a path find. But then that's just extra time, and I'd rather just, I don't know. Is it gonna be too terrible to type this all out? We're almost done with A, and we did already a hallway. It's not that terrible. As long as I don't have any mistakes here. Which I probably do. Well, who am I kidding? All the A1 starting points, A0 is the same with an extra step. Oh, I'm not done with A1. Damn it. Sure. Actually, it's like this one. Only these go to the D with an extra hallway traversal. This one's the same as that one without the D1. Okay, and then let's just do this here. We go to hallway right 0 immediately. No, it's the deepest one, so we have to go to 1 there. Right? From CD, it's just 1 step. No, it's 2 steps. Okay. What kind of nuts? Peanuts or something harder? I don't know, Endurin. I don't know. That doesn't belong there. Okay, now all of the room A1 starting positions copied to A0 with an extra step. C, D, 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 hallway right. Okay, here we go. Room A1. room A0. And these all get a position room A1 first in front. Oh, I should double check that I did this for hallway left. Thank goodness for auto formatting. Okay, hallway left 0 and hallway left 1. Yeah, okay, that looks good. Okay. Hallway AB to room A1. AB to A1 is just there twice, really. And A0 is just an extra traversal. Like that. Okay, and then B1 has to go through hallway. No, it just goes directly to B1, right? We're already between them. B0 goes to B1 and then B0. Okay. This is the one that requires the extra traversal. Before we go to C, we have to go through hallway BC. And then one less step to there. D. Yet another hallway. CD hallway. I'm at the end I'm gonna really regret doing all this. I just know it. I know it, I know it. Okay, and then this is just immediately into hallway left 1. Like that. And this is one fewer step, right? 0 is the deepest hallway. 1 is the not so deep hallway. Okay. Oh, wait, what am I doing? This isn't right at all. I started doing the hallway B1. Shoot, I messed up. B1 to hallway left is go to AB first. Then hallway, then we go directly to hallway left. Okay, yeah, I messed up. Okay, so to get to room A0, it's directly into A1 and then A0. Okay. Like that. Okay, hallway AB, we can do that. That's like that. Should be doing your programming homework or doing your programming job. Instead, you're watching a guy programming. Think of it like we're co-working. You work on your programming homework or your job, while I work on this, and it's like I'm the guy next to you or behind you also working, right? Sometimes I'll do that. I'll just have someone else I know who's a programmer on Twitch on in the background while I'm going, so I get the sense that it's like we're co-working on different things. B1 to B. Okay, so that's just directly to the hallway. And then C1 we get to through the hallway for BC, right? And then C0 is an extra step to C0 from there. Too many vectors. CD hallway. Easy. Okay, and then the D is just an extra step. Once we get there, extra 2 steps really. Like the sound of that's not my idea. I've heard that a lot on Twitch. There are actual streams you can find where the person doesn't talk. There's just chill music in the background. And it's just so that you can look up and see someone on camera also working. And then you just get the sense that you're not alone. You know? Okay, room, right, D0. That's the deepest hallway. I need to get there by going through 1, like that. And then this is 1 fewer step. Okay, so all like I did with the room A, room B0 is like B1 with 1 additional step. So paste that. Find where room B1 resets here. Or I start over the enumeration really. Okay, and that's 0. And there's just an additional step here. Position room B1 at the beginning. Getting there. Getting there. I think I'm halfway through. Oh, that needs to be an empty vector. Borrow that step. Okay. All right, we're on the right track. So hallway BC. Actually, can I just take hallway AB and remove some steps from that? Hold on. Let's see if this works. Yeah, let's take... Actually, let's not do that. This might be the different set of... No, it's the same. Never mind. We can do this. So, hallway AB, right? Instead of hallway AB again, it's hallway BC. And then what do we need to insert here? So, remove these, because we're already in hallway BC. Right? For room A, we have to insert hallway AB into the mix. Twice. Oops. That goes there. Okay. A, B, A, B, A1, A1. Okay, that looks good. Just remove directly, go through CD. Okay. Alright, so... only 2 more rooms and 2 more hallways to deal with. I'm ready to just end it right now. End the game. We'll keep going though. We'll do this. C1 to hallway left. C0 first. Then hallway BC twice. And then AB twice. And then hallway left 1 twice. Right? And then the deeper hallway left 0 has an additional move. Okay. Move to room A1. It's A1 instead of room left. A0, it's an extra step to room A1. A0 from A1. AB, that's fewer steps. We already get to AB there. B1. We go directly to room B1, don't we? To move to B0, it's an extra move into room B0 after B1. BC. we already get to BC in 3 steps. Room CD, we go directly to CD. D1, we got to go through CD, and then we get to room D1 in 2 steps. D0 extra step. I feel like I'm getting a little bit faster at this, but maybe not fast enough to not put people to sleep. Hey, that's a alternate benefit of watching my stream right now. It's so boring and repetitive that it'll put you to sleep. It's like by design. Okay. Really, this is all just setting myself up for humiliation where this entire algorithm just doesn't work at all. C0 to the same as C1 except for there's an extra step. Right 1 is what I'm looking for up here. There. C1. Actually, it highlighted in yellow. I didn't even really need to look. To 0? Okay, and then that shouldn't be there. Okay, I messed up room C1 then. Hold on, I gotta fix that then. Whoops. Delete that, delete that. Yeah, these are all wrong. Oh wait, no, they're technically right, but I need to put a 1 there. 1. I just had 1 shouldn't go through 0 though to get to the hallway. Yeah, these are correct. The other ones had an extra transition they shouldn't have had. I'll get this. I'll get it. Stay with me. Okay, so here we don't want these extra C0s in there. Delete. You know what they're going to do is on part 2, they're going to be like 26 rooms instead of 4. And then it's going to be like, okay, got to solve it a different way. I'll do it tomorrow or something like that, right? And at that point, I think I just do pathfinding rather than having this route clear. We just do a pathfind. Which probably would have been a better idea than hand coding all this junk. But sunken cost fallacy at this point, right? Okay, so this is going to hallway BC first, then hallway AB, then there. Room A0 is almost the same, only an extra room transition there. Okay, BC, or B1 is, we don't go through that hallway, we're already at B1. Ah. Would have just done A star at this point, I know, but you guys know what the sunken cost fallacy is? I'm totally a victim of that now. It's like, I've already put all this time into it, I'm almost at the end, I'll just keep going. BC, actually, we're the CD hallway, we don't need to go to BC, we just go straight to room C1. Actually, that I'm going to copy here to save myself a tiny sliver of time. There. And then, actually, it's the same there, except for it's room D1. And same here. D1. And then D0. Okay. Final room and final hallway. So we got to go to hallway CD first. Then we got to go to hallway BC. Then AB. And finally hallway left 1. All right. And then 0 is just extra step to 0. And these are slightly shorter paths. That's that. Actually, this is a slightly longer one. Needs to go to that final step there. Wait, what? Oh, I get to press the button. There we go. I hope else Exeter, you're talking about the bot. We deleted the bot's message. I don't want to become famous. I want to become infamous. I'm waiting for them to open up a new website called Wanna Be Infamous, because I want to go there. All right, hallway AB is our destination. Room B1. We get straight from the hallway. This is an extra move. BC hallway, we get there straight away. C1 is straight from that hallway. This is an extra step. CD hallway, we get there in 2 moves. Okay, right 0 is the deepest hallway. I guess I've ordered these differently in some places. Actually, we don't go through CD to get there, we just go straight there. Yeah, and then this is 1 fewer step. Okay, and then the D0, same as D1, only extra step. So copy, paste, we go. So it's just a bunch of D1s in front. Or, I mean, D0. Oh, sorry. All of these yellow squigglies are because I copied but I didn't rename. It's basically saying you've covered that combination already. There. Was that already there? I think it might have been. Okay. Hopefully so. Because we need just to add it to all of these. Okay.
Because she dies.
One final hallway to deal with. Thank goodness. Hallway right 1. And then we're going through hallway CD, hallway BC, hallway AB. Oh no, these take 2 steps each. I need to make sure I do that right. Wait, did I miss a step? No, I didn't. This goes to hallway, yeah, let's just fix this. These each take 2 steps. And then this goes to straight to room A1 in 2 steps. Okay, I can do this. This is just an extra move. So close to being done. We don't need to go to hallway B. AB, I mean. This actually is the next one. I should have done that one first. Because that one is just that. Okay. Do C0 first, so we don't need the B hallway. Making mistakes. Alright, and then C1. There. It's like I'm building up the suspense, right? It'll be like I'm getting closer to my doom where I realize that this won't work. And then everyone can laugh at me and then I'll cry in a corner, right? We're getting close to a moment of doom. Okay, so hallway 1 is the same as hallway 0 except for there's one fewer step.
I don't. That teleport's just a better spell. Because, like, you can do much.
Here we go. I let the yellow squigglies light the way.
Bottom now. Teleport.
Then one fewer step.
I was trying to figure that out.
So close, I can taste it.
Light up the board behind.
I'm being followed. Thank you for following me.
But they are very push-ups.
Okay, you ready for this to totally break? Because that was the last bit of code. I have no idea if this is going to work. Should I just hit go and see if it works?
Actually, don't come to your jungle.
Here we go! Alright. It's taking forever. So we need to verify a few things. There's a bug somewhere, or the algorithm is insanely slow. So what if we, it'd be really cool if we could print out this. Wouldn't that be really cool if we could just print that out? And then we could print it out every step that we try. I think that that's such a cool idea that I'm going to go ahead and do that, and it'll be another function called like up here called display positions. And we're going to do a print line of this. 1, 2, 3, 4. 1, 2, 3, 4. The bottom one has 2 spaces. There we go. I don't even need those spaces. What am I doing? These ones right there, there, and there. Not there. There. Have a couple characters to print. This will be positions dot get position room A0 unwrap B0 C0 D0 with a whole bunch of borrows. Right, and then the line above it is actually that, but with the ones in there. Right? But there's also walls. And then this is the magical one where you have a whole bunch of hallway things. So these 2, then 2 over, and then 2 more over, and then 2 more over, and then 2 more over. I messed that up. 1, 2, 3. Okay, it's 3 in a row actually. 1, 2, 3, and then 2 over, and then 2 over, then 2 over, then 2 over, and 1 over, I think. No, I did that wrong. I'll just hand do it. 2 left, space, or a dot. Actually, let's do space instead of dot, because I'm actually just using space for empty right now. Yeah, then hallway, space, hallway, space, hallway, space to the end points. And then it's just a bunch of these. 7 of them. 1, 2, 3, 4, 5, 6, 7. Hallway left, 0 for the deepest, then 1, then hallway AB, BC,
It's okay, she's still
CD, and then the rightmost hallway starting with the outermost and then the innermost. Okay, now let's just test this by just displaying our initial positions. So
she
right here, I guess, we'll just display positions. Borrow that sucker. Run it. So we have BA, see if this matches. BA, CD, BC, DA. Looks good to me. Let's also show the solution. See our solution. A, B, C, D, C, D, D. Looks good. So that much is good. The infinite loop, not so good. So I think what I want to do is every time solve gets called,
he is a move.
right when we're going to call this new, when we find this new positions, I think, is we'll display it. Although I bet this is going to fill my screen with junk. Let's see what it actually prints. Yeah, it filled my screen with junk. Let's take a look at the junk. It's too much to display. Actually, why does it show that one? Oh, that's weird. Okay, too many to display. How do I do this? Actually, you know what I'll just do is I'll run it. Cargo run 22. Are we on day? We're on day 23, right? Yeah. And go to an output file. I'll just let it run a little bit. And then I hit Control C. And then we can open that file. And there we go. So this is given my starting positions. It first tried to move the A out to there. And then it said, okay, I'll move that A out to there. And I'll move that D out to there. And then I'll move that C out to there. And then I'll move that B out to there. And then that didn't work, so I'll move it to there. And that didn't work, so we'll move back and try the C out to here instead of there. Yeah, trying all these different positions, right? And then it's trying to backfill them in the corridor. Oh wait, it found one in which the D's are there. There we go. So it got the D's in the right spots. Oh, and there's where it got a C in the right spot. But then what, it gave up on that one? The initial one was CDBB. So here's where I got a B in the right position. I think I do need to have, like, prioritize them because I think it's just going to take forever. The brute force is just too much for it. If I scroll really far down, is it getting into the combinations where... Oh yeah, see? It's starting to get combinations where it's almost solved. Look at that. Actually, it found a solution. I should have it print something when it finds a solution. Let's do that. This might be working, and it might just be too slow. Where do I get a solution? It's right here, right? Print line. Found solution with energy. Yeah. So let's run that again. Let it run for a little bit. Okay. Looking at that file again. There we go. It's finding solutions. I guess there's just too many possibilities. Too many combinations. Okay. So that probably that tells me I probably should prioritize moving things in a certain order, and then if we know that out of curiosity, how if I just let it run in release mode, maybe it finds a solution finally and isn't too slow, that I can just go with it. Thread sleep, moment of truth. I can possibly debug that, though, if it fails. If it fails, I'll probably see something really weird, but I didn't see anything weird. A release for the win, yeah. I don't think this is gonna work. I think there are just too many possible games, or too many possible combinations. I think we have to start pruning. Actually, hold on. We can prune quite a bit, right? Because we can keep a running track of the short least energy, because we're finding solutions pretty early on, right? That was weird. The mouse stopped working. We don't need day 22. Yeah, this file is huge. Look at how many lines it's got. It's got 6 million lines. Found. So within the first 151 lines, we find a solution with that much energy. We can just start like abandoning it early if the energy is too high. Right? Because when we start finding ones that have more energy, I don't know why. Yeah, like these we didn't even need to explore because it's not worth it. So let me think about how I might be able to prune these things away. What if we give solve like the lowest energy solution we know so far, so best so far, and actually I don't even need this, do I? And think about this. Actually, yeah, this would be like an option. Use size. Okay, and then we have to pass it along down here. But here's where, like, if this is larger than the best so far, we don't even need to call this at all, right? So what we can do is we can say let next energy equal that. If next energy, if let some, how about if matches? How does matches work again? Right, it's the thing and then the thing to match with. Next energy. No, it's it's best so far. If next best so far, some energy if energy is greater than, is less than energy, or actually equal to, plus move. I need another symbol for this, so like best energy.
Nice, dude, I stunned her.
Then do nothing. I guess we just do continue. There. Then that can go here. So if the best energy path we found so far is better than the one we're currently following, we're just going to skip that possible move, right? We're going to skip it. Otherwise, we're trying to solve there. And if we find one, then we got to update the best. So let's make that immutable. And we'll say if, again, matches, I guess. No, we'll just reassign it, right? No, it has to. We have to do this again because it's possible we might have gone over. If matches best so far, best energy. If energy is if it's okay, so this is a total energy. So if that doesn't match, basically, then best energy equals sum total energy. Why can't I? Oh, best so far. At the very bottom, I gotta say the best so far, we don't know. We don't know. Okay, does this look good? With a possible move, we have how much energy that's gonna cost. And if we've already found a better solution, okay, this should be that. If we've already found a better solution, we don't even consider it. Otherwise, we try to find a solution. If we find it, and it's, and the one we had so far, I have to be careful about this not. If it's not the case that we have some better path, then we found a better path now. And actually, then I would do this, right? Why was it that I was making... Oh, this is just to find the minimum, so I don't actually need to do this anymore, do I? I can just return the best so far. Yeah, so this is just best so far. And I don't even need to push the total energy in the list. Alright, so this goes away there. Yeah, okay, let's try this. Please finish, please finish. Build and finish. Finish, please. Please finish. No, you're not finishing. Okay. Cancel. What did you print? A huge file. It's just finding a lot of paths that are pretty good. Should I have let it run longer? And maybe have it print out, let's have it not print out the display positions. And then I'll just not redirect to a file. Okay, it's finding solutions. It's not finding any better ones, though. Is that the answer then? Is 16,288? Then why is it never finding the end of it? Let's have it only printed if it actually gets better. Well, yeah, I should have done that. There we go. Let's try this again. It looked like it quickly converges. Wait, the last time it ran, didn't it get a better number?
Oh my god, so huge.
Hold on, what's different there? Oh, this should be, No, that's correct. Why did this print a different number then? Oh, because it never had... Okay. No. Wait. Why did that print out a different number, a lower number? Is that number getting larger? Hold on. Yeah, it's getting larger. No. I'm getting confused. Why is that lower? Shouldn't that only print it when it gets lower? And why is it printing larger numbers here when I do this? Now it's not. Why am I getting a different answer? And why is it printing it more than once? Oh, probably because it's doing that all the way back up. Probably. I don't know what I did then. It's giving me a different answer each time. How is that possible? Why? How is that possible? That's giving me a different answer every time. Is that because I'm using hash map? I guess it's because it's using hash map and we're getting a slightly different... No, how would we get a different answer? Yeah, shouldn't it be deterministic? Shouldn't it be?
Colin, I remember when you were excited about that.
It seems non-deterministic. How is that possible? How did I introduce randomness into here? That doesn't make any sense. I've made a random number generator.
I'm here, Colin.
How did I do that? How did I make a random number generator?
One of them.
Oh, that's funny. What could I have done that introduced randomness? I mean, does hash map introduce some element of randomness by the memory locations it's getting? I mean, I'm consistently getting numbers. I could make a guess with that number. Might as well, right? No, it's too high. So there's a better one. Please wait 1 minute. We'll let it run. We'll let it run for a minute. What's interesting to me is that it stops finding something better. No, actually, that shouldn't be a surprise to me. The space is just too large, and for some reason, it's picking a different order, maybe because of the hash map. While that's running, let me look, see what could possibly be different about this. So we call solve. Solve goes through, okay, this is gonna do it in a possibly different order if hash map picks a different order for some reason, which is really weird to me, but I guess it's possible. I mean, we're not doing something stupid like mutating it when... No, we can't be mutating this, right? Because this is borrowing it immutably, and we can't change it. Rust wouldn't let this compile. Try B-tree map, see if it gets deterministic. Yeah, good point. Well, the non-deterministicness of it maybe will get me a lower, like converge to a lower one quicker. 16,288 is the smallest I've... No, 15,366 is the smallest we've gotten. No, 15.366 is found there.
He's running.
Interesting that there's one that's exactly one more energy than the other. Okay, then I guess while it's running, we'll change it to be B tree. How many times did I say hash map? 10 times. Not too bad. So we'll just change hash map to B tree map. Import it. We can't call get on a B tree map. Ord is not satisfied. Well, we can change that. Ord. Partial ord. And then it told us, yeah, okay. So then try again with the B tree map. So this should be fully deterministic, right? Guaranteed. So there's one run. Yeah. So there must be something in hash map based off of like memory locations or something. I guess that it's considering memory locations when it's hashing it somehow. I guess. What else could it be? You know, since it's not printing it as much, can we like show the path on the way back out? That might be fun to double check. Yeah, so I can, when we find a solution, we'll print out what our original positions are. Print, no, display positions, right? Yeah, exactly that. So this will print out in reverse order the path that it took. So we can see them move like if I... So the 15,368 one is... I guess we have to read from the bottom up, right? We move the A out, then move the other A out, then move the B out, then move the D out, and then put the D where it should go, and then...
Dude, I'm not taking this. I don't have that.
Wait, what? Why did it move the D into the hallway and then store the B? I guess it didn't... The order doesn't really matter. D moves out of the way, then B moves into its position. And then...
Nice stopwatch.
I'm looking for mistakes. What's different? What goes from here? That's where B gets stored. And then what's here? The C moves out. And then the A moves into position. And then
Ooh, I could make Rabidon.
the D goes home. And then the C moves out. The B moves out and then goes home. The C goes home, and then the other C goes home, and then the final A goes home. Okay.
Let's just throw it at the beans.
So one thing I noticed is that it's considering it into two steps, moving it out into the hallway where it should just try to go home directly. So I could maybe speed it up a little bit. There are fewer routes to consider.
I want something like it.
Have it go directly home
I'm stealing the Lux.
if it can. Favor that solution, because it should be better than going out into the hallway first, right? Yeah, the final should always be a terminus. So let's see if that improves it.
The other one I'm scared of is this. No.
Romania Height, hi.
No,
Your name is very similar to someone else I know called Romania Hate. Unless you are Romania Hate and you changed your name. Hello. Otherwise, you have a very similar name to someone I know. Wait, what? Yeah, because they ban your account? Kappa, I see.
Getting married.
I could look at my log here to see if you are the same person. Unknown user. So you're not the original Romania hate, because if you were, my bot would have detected your username change. Huh.
I'm doing
No, unless... Oh, wait a minute. No, so you created a new account? So then, yeah, I can't really tell if you're telling the truth or not. You'd have to tell me something that only the original Romania hate would know. Why would, and then if that's true, I'd be really curious,
this is the second time.
but you wouldn't have to tell me why they banned your account.
That might be G.
Account. Weird. How did you get your account banned? Okay, yeah, in the solver, I want to favor the,
It's the only one.
okay, the find possible moves, basically. If we find a final position... This one, this route. In the route, we should favor the final positions. Right? In fact, I'm not using occupant at all. That's a sign. We're only using occupant for energy. This gets complicated because the destination room A1 and A0 is only
I'm almost in
The-
range to ult them, calm
the
down.
best path. Like... Oh, wait. No, it's not route clear. It's the caller route clear here.
Yeah, she's
Oh, no, we did favor the final position. Then why is it moving to the hallway first? Oh, I see what we did. Okay. I don't want this if, actually.
stopwatch.
I don't want that if at all.
Squishy.
I want to get rid of that if. That if didn't make sense, right? Yeah, we don't want that if. It doesn't matter if we're in the hallway.
Support.
Whether we're in the hallway or in a room, we want to try to move to the final position, right? It's if we are not in a room. If we're in a hallway... Oh, wait. That's a bug then. This says if we're in a room, only try a hallway. That's not what I want. Always try to move to a room. Always. Yeah, always try a room. If we couldn't get to the final room, then if we're not in a hallway, try to move to a hallway. Yeah, that's better. So always try to move to the final room. If we can't, then try to move to a hallway if we're not already in one. That might cut it down a bit, right? So let's run this. Ooh. Now it's not finding a solution at all. Okay. What did I break? What did I break here? Find possible moves. If that would be, yeah, find some route from the position to the room.
This is gonna be great. You just look at
Occupant. Oh, wait, We want to return immediately, actually, not just push into moves.
Character work.
All these push moves should be return immediately. Yeah, should be return vec that.
Vigilance character.
Yeah, that's a shortcut to the end. If this doesn't start printing something, then I mess something else up. I panicked. Oh no! 1459. 1459. Oh, it didn't find any solution. Okay. I messed something up really bad then. So maybe we'll just display all the positions up to that point that we tried. Okay, it tried what it thought was all possible moves, and it didn't find an answer, so we must have messed it up. Let's see what it tried. So it first tried... Wait, where'd it go? Oh, I think that's a bad... It's in a bad state now. What was the original? AC... Oh, it moved it on top of it ate the C. Okay, we can't do that. Yeah, that's not allowed. Okay, so then we have a bug. It thought it could move it there even though it was occupied. So where is that? Here. If final position, if some route, it thought the route was clear to room A0 from A1. So how is that possible? From A0 to A1. Wait, what? Where's A0 to A1? Oh. Is it missing? How did that happen? Hallway left 1, left 0, A, B, room B. Oh, it's missing. So what would it do if it's missing? It would go all the way down to the bottom, right? And return no possible move. What? Oh, wait, hold on. This vector is what exactly? Oh, it wouldn't go into here at all. Oh, shoot. This is totally screwed up. What did I do here? I said 4-step in match, so for all the steps, we check. If it's occupied... Oh, right. So so I messed up then. We're missing some transitions. So we're missing from left 1... We're missing from room to destination room. How did that happen? I don't know. Okay, so here's one we're missing. We're missing A0 to A1 to A0. And that is a 1-element vector. Just go, whoops. Room A0. I'll just type it in. Vec position room A0. Okay, I'm probably missing B1 to B0 then. It doesn't make sense to go from A0 to A1, so that better not be there. Yeah, it's not in there. Okay, I don't know how that got dropped. I must have just made that mistake. Yeah, okay. I think I remember making this mistake, actually. So we should just list it first always. It's like the special rule where you just move straight down. But that should actually never happen. Oh, that's why I didn't think it was possible. But we should at least say that it is possible. But it should check and see that there's something occupying that, and then it would stop. Okay, that makes sense to me. Okay, we're saved. I just need a C1 to C0 and a D1 to D0, and we're good. To D0. D1 to D0. This is like the routing from hell. This is still part 1, by the way. Okay. I'm just going to have it go a little bit and hit Control-C. Just so I can look at the output there. Yeah, see, it's no longer considering eating C anymore. So, these look reasonable, right? Did it find a solution? It did find a solution. Look at that. It's finding solutions again. Wait. I thought I saw a solution in there. Why didn't it call it a solution? Oh, probably because the cost is too high. We should probably have it print that out. Because there might be a bug in where it's not pruning those branches soon enough. So, where was that? Solve. In here, right? Actually, right here. Print line. Energy spent so far. Next energy. And we'll just not print it out if we skipped it. How about that? Sounds good to me. Let's go. Hey there, Rasubaka. Country name plus hate is hate speech towards a nation. Really? They banned you for that? Come on. Really? I'm sorry, Romania hate. You can't even write the word hate speech, really? Should I not even say the word hate speech? Come on, we all know that Romania hate is not a hate speech. Out.text. Okay, so yeah, 2 energy, and that's 302. I'm interested what it gets to when it's way down here. Oh, wait. Once it finds this, is it because the best is better? Found solution, right? Okay, so when it gets down here, it doesn't find any more. So what's the best so far? It'd be more convenient if I had it print out what the best was when it got down here. That would have been smart. Let's do that, because this is too hard. Best is blank. Best so far. Run that. The irony of misspelling typo. I know. So ironic. Wait, didn't it find a good solution down here near the end before? Yeah, here. Oh, wait, D is intractably too far away. Oh. I wonder if we knew that it was too far, we don't even need to try anymore. Maybe that's the next level of optimization here, is if we know we spend a certain amount of energy, and we know it would take too much to get there, we don't even try any more combinations? Because I think it's probably getting stuck with D on the side there, and it's like, I can't move that. There's no way I can move that back. Okay, so we can comment this out again, right? And stop printing out text. Let's just see it run. So it's finding some solutions. We're back to 15.366, which it told me was too high. So it hasn't found a better solution yet. Did the example have a fast solution? What did it say the example was? 12,521. Oh, it says it, but that's the one we tried and it said it was too high, right? So maybe the calculation's just wrong and it did find it? Okay, so we can look at that. Let's print out some more stuff to help. We'll print out like how much energy that the single move took. So I can do that here. This step, some number of energy, which is next energy, right? Move energy. There we go. Let's print this out. It'll be displaying it in opposite order, but we can at least look at it, right? Or is it in order? Oh, let's print out one more. This step out of so move energy, and then it's like next energy. Right. My watch is telling me I gotta go to bed. That means I've been spending like 2.5 hours on the problem. Okay, so let's read from the top of this. Where do I start reading, though? Oh, right, it's from the bottom up. Yeah. So I have to take this solution and look at it in like a new file here. Okay, and then say that it's not CoffeeScript, it's actually plain text. So then here's our initial thing. It says this, we took 2 energy. That looks correct, right? 1, 2. And then this one, next one took 2 more, so we moved the A out again. And then this step took 70. And it's moving this B, right? 1, 2, 3, 4, 5, 6, 7 to there. Correct? And then 7,000 to move the D over to... Oh, to move this D to its destination. 1, 2, 3, 4, 5, 6, 7. That's correct. 7,000. And then 7 more thousand to move the other D in, right? 1, 2, 3, 4, 5. Oh, no, that's wrong. It's off by 1,000. 4, 5, 6. Okay, so I have a bug in the number of steps to get from room B0 to D1. That's what that tells me. B0 to D1. Room B0, comma. Room B0 to D1. Here, this is wrong. Why is this wrong? Let me think about this. B1, then hallway BC twice, and then CD twice, then 1, 2, 3, 4, 5, 6 though. 1, 2, 3, 4, 5, 6. So what am I not thinking of here? Oh, I'm looking at the wrong one. It's B1. B1. Where's B1?
All my potions.
B1 to D0. Here it is. No, B1 to D1. B1 to D1. Here it is. 1, 2, 3, 4, 5, 6. Why does it say 7,000 then? Oh, it is 7,000. I was looking at it wrong. Here to here, and then here to here. They're both 7,000. Okay, never mind. We're good. Next step is 30, and that is moving the B into place. 1, 2, 3. Correct. Then 300 to move the C into place, right? Yeah, this one. Oh, this one out to the corridor. 1, 2, 3. There. And then 4 energy to move the A into place. 1, 2. No, that's wrong. That should only be 3. Okay, so that's hallway left 1 is wrong. Left 1 to A0. Oh, yeah. That's wrong. 0 is deeper than 1. Those shouldn't be there. Okay. Good. I think I was just off by 1. Or something like that. Okay. Better. Hallway left 1 needs to go through 0 though. Oh, wait, no. Wait, hold on. I'm wrong. I'm wrong again. 0 is deeper.
Oh, yeah, some things are just past.
It's, that is hall, I'm getting myself confused. Yeah, that shouldn't be 4. That's hallway 1.
Yeah.
Left 1.
Pure past.
Right, so this, Yeah, these are all wrong.
One champion with that.
These are all wrong. These are all wrong. All wrong, all wrong. Delete them all. These are wrong too because we have to go through hallway left 1 first. Yes, okay. Good. Found a definite bug in my pathing. Okay. Now, how much do you want to bet I have a similar bug on the right-hand side? Let's look. Hallway right 1. Well, right 0 is the innermost. It has to go through hallway right 1, and it is. Okay, so I got that one right. So am I just off by 1? Is that what it comes down to be? Let's see. I was off by 1. I was off by 1. I was off by 1. Hey there, M. Perry. Perry says bed. No, I got to solve it. I needed to at least get part 1 done, right? And we did it. It's horribly brute forced. In fact, it's still running. So probably I'm going to completely get crushed on part 2. Let's see what my doom is this time. Oh yeah, it just gets deeper. Okay, so we're going to just have to do pathfinding, right? As you prepare to give the amphipods your solution, you notice that the diagram they handed you was actually folded up. As you unfold it, you discover an extra part of the diagram. Between the first and second lines of text that contain amphipod starting positions, insert the following lines. DCBA, DBAC. Great. So they still want to be organized into A, B, C, D groups, right? So, okay. Yeah, I'm going to cry in a corner now. This really huge thing we're going to have to do away with, and probably this makes it impossible to brute force now, right? Unless maybe I let it run all night. I don't know. It's possible that we could get it to work, but let's put the answer in there. So it's the same puzzle, only we had to insert rows. So part 2 is like part 1, only slightly different. We insert, this is burrow. Yeah. We have to expand this. Or I get more intelligent about how I represent the rooms. It's not horribly much. It's not too horrible compared to what I thought it might be. I thought that they were going to introduce more hallways, actually. But they're just introducing more room levels. So like a depth 2 and a 3 or something like that, right? So to simulate this and then make it work with part 1, I guess what we say is we can just pre-fill these even deeper rooms with the correct solution. That's what I'm going to do. For we'll just add new rooms, but they'll be even deeper rooms. So they'll be like, see, right now the problem is 0 was the deepest. So really, it's not the deepest anymore. How about I do this first? Before I do anything, I'll rename 1 to 3 and 0 to 2 and 1 to 3 and 0 to 2.
I'm so dumb.
1 to 3, 0 to 2, 3, 0 to 2. Right? And then I just introduce more rooms. But I'm not going to go through and do that work again to compute the pathways, because now that's just almost going to double the amount of time I have to spend on it. I think I'm going to try to find a better solution for doing the pathfinding. But I want to at least represent the unfolded rooms correctly and make it work with my part 1 solution. So to make this work, I just have to pre-insert into rooms A1 and 0 just the letter A, right? Yep. And then same thing for B, C, and D. B1, these are all B's. These are all C's. These are all D's, right? Yeah, and then the solution too. Actually, I don't need to do that because the solution started out with the positions cloned and we're just rewriting the outer rooms. So I don't need to do that. I can go ahead and update, what was it? Where was it? That function, we gotta fix that, right? Where is my functions? Display positions, right? So we just need to make it deeper, right? 2 more rows. So we get 1s there and 0s here. And then that should still give me the right answer for 23.1. It's just going to show the rooms being deeper, because it's not going to try to move anything out of the innermost rooms, right? Okay, I messed it up somehow. It should have started finding solutions. It's not. So just to double check, let's print out the initial position. So go to part 1 inner, display positions, and solutions. Solution. That's correct, right? So then my search replace should have worked. Oh, hold on. We need to throw out all the ones that start in or end in the innermost rooms for now. Okay, this is just temporary, so we'll just do it like this. Position room A0 to anything, or A1 to anything. Actually, rather than doing this, what if I just return none? Yeah, that would be even simpler. Return none. I should have just done that from the beginning. There. No path unless it's one of the ones I define. There we go. Fixed it. Right? So then just to do part 2, I need to redo the pathing. Because I don't want to go through that terrible hand editing. Just to add more paths to and from the innermost rooms. So how to do this, right?
Wait, echoes their midpoint, not the jump, I just realized.
I just need to form a graph, right?
I just realized this is the first time I've ever
Yeah, I'll do it with just a simple breadth first would probably be good enough. I just need to form the graph to go from that represents all of the paths you can take through here. And I need to make the edges such that, like... Actually, no, I don't. I just need to make the paths, right? Are there any paths through here that should not be allowed? I think any path should be allowed. Because there are no loops. If there were loops, like if there was a back hallway, it would be really nasty, and I'd have to start thinking about edges. But don't really need to do that here, right? Yeah, I don't need to worry about that. So we're just going to redo this function. This ugly-ass function here that takes up most of this. And we can do it and test it with part 1 and then see if it's good enough for part 2. If it's not good enough for part 2, then we got to optimize more. So let's envision that route clear. Oh, I need to update this too. Dang it. I mean, I just need to extend this by 2, right? Yeah, that I can do. That I can deal with manually. So it's like prefer room A0, then A1, then A2, then A3. Oh, but only if
Yeah, okay.
where is it? Oh, final position is going to get more interesting too. Yeah. So yeah, let's update these first. These need to be updated regardless, because we need to prefer the innermost rooms. We don't want to have it stop with a gap, because those will not lead to any solution. We can't block our siblings, right? We have to try to pack it in without any spaces between. So I just need to do that with D now. 0 and 1. Okay. And then this needs to be updated. So we need 2 more ors, and they get increasingly complex. Actually, the complexity is the outer one. So it's if this is... Hold on, too many parentheses?
I don't know, he's stolen a lot of kills.
Oh, I have the in the wrong place. Okay. And Yeah. So this is we did inner first, right? Okay, then I did this wrong. Inner or 1 or 2, and then as we go, this is a 0. This is a 1. Okay, and there's 2 more ands, and this one has 3. One, 0 and 1, 0 and 1 and 2. And gets rid of some parentheses. Okay. What's it telling me? Is it complex? Unnecessary parentheses. Correct. Okay. Does this make sense? So it's the final position if it's the very back of the room, or it's the next position and an A already is in the back, or it's the next position after that and there are 2 A's, or it's the last position and the 3 A's. So then this just changes. Actually, to make this easier on myself, I'm going to replace this with occupant.
Honestly, it's not that bad. It's annoying.
Can't do that. So I'm not going to. Can't do that in a matches that easily. I could probably do it with an if, right? But I'm not going to bother. I'm just going to do it like this. Change them to all B's. Change all of these to B's. Change all of these to B's. Just need to do it 2 more times. Now you're probably saying to yourself, Raimu, why are you copy pasting, man? Why can't you just do this in one thing and call from 4 different places? My answer to you is, I can't think like that this late. Hey there, Endurn. My son also streaming something? I don't think so. I think he's playing a game behind me. You can hear him though? You shouldn't be able to hear him that well. Paste that. It's copy pasta. Okay. We extended the room. The hallway, did I actually ever use that? Final references. Yes, I did. I used it in one place. We extended the rooms. We did not extend the hallways. The input's the same. Final positions we updated. Find possible moves. I extended those. Looks good. Okay, route clear is the one we need to rewrite because it's a stunning 1,200 lines of code. I don't think solve actually changes unless we need it to be like more performant. Okay, so for part 2, let me just do it because I don't have it done it yet. But we don't insert A, B, C, D. We insert D. It gave it to us backwards, right? D, C, B, A. D, C, B. Oh, I have this wrong anyway. It listed it in outer rooms first, right? Outer rooms first. So the outer rooms were D, C, B, A, and then the next room is and it's not the outer, it's 2 and 1, right? So it's 0, 1, 2. So 2 is D, C, B, A. And then the next one's D, B, A, C. D, B, A, C. There we go. Alright, I'm not looking forward to it, but we gotta do this. Oh, I never ran the test to make sure it worked. We should do that, right? It should get 12, 5, 21.
I don't like this root.
Actually, but it might take forever because it's debug build. Oh, there, it found it. Should I just can it early? Can it.
Get my item.
Yeah, I'm not going to be using the unit tests. It's just too slow. All right, rewriting the monster function now. So I think the way to do this is to have a visited.
Push it up.
And
It's CS. Okay.
this is a B tree set
Yeah, that's nuts.
position. Import that. We can go back to hash map too, by the way. We want a. All right, we're already returning a cost out. Yeah, okay, and then, yeah, the other thing is we need to have the paths. So, how do I want to represent that? I think we just make it a B-tree map from position to position. No. A B-tree map from position to a vector of positions. There we go. So let's delete this. Now that I've written it all, I can delete it all. Okay, before I do this, let me save it. All right. How is that all staged? What the heck? Why is it marked as staged and deleted? When did I hit stage here? I don't know. It's been too long. I already forgotten why I staged it. Okay, stage it again. That way, I can get back to this later. Okay, delete all this mess. All the way down. Most of our code we're deleting.
I do damage, Colin. Not that much, but
All right.
ruin up.
We still need this core, right? And this. But the way we get the step is by enumerating the paths from the current position. So it would be 4. And we're going to call route clear recursively. So for what next position? Step. First step in paths.get start. Right? Borrow the start. Do I need to borrow that? Just no, iterate that, right? No? How do I iterate? If I'm borrowing, if I have a vector positions, how do I iterate that? Into iter? Why is that giving me a vector positions? Oh, it's unwrap, isn't it? Yeah. It's late. It's getting late. Can maybe hear him when I'm not talking? Yeah, that makes sense. That means the noise gate is not aggressive enough, probably. Didn't used to need to be this aggressive. Okay. Yeah, if it's occupied, then there's no path. So instead of returning none, actually, don't we want to just continue? Yeah, we want to continue here. And well, actually, it's if it's clear, then we want to hold on. We know the energy, right? We can just do that right away. let energy equal. Actually, I can do that at the very beginning. Yeah, my son's still coughing because he had like the flu like a couple weeks ago, and he's got like this long cough now. Not COVID because he was tested. Okay, so these are all the possible, but only one of them will actually reach there. So actually what we do is if we say if step equal destination, well, we do that here, right? We should do that first, actually. And in this case, it's none. Return none. Else.
I don't like my phone. New rooms.
Yeah, then we would put this in there. If we get out of here, then that means we couldn't find a path, so none. Okay, let's see, did I get this right then? Return some there. Okay, so but if it's not the destination, if it's not occupied, we want to attempt it.
It's probably like
If it is occupied, then we try a different path. Right, so if it is unoccupied, then we want to say if let some new positions, not like this. Uh-oh. Do we have another UK versus EU battle going on in chat? Watch out, they both have swords. One good side effect of that is they can't ban each other because they're both at the same level. Only I can ban them. UK number 1, EU number 0. Wait a minute. Oh, it's 0 based. There we go. This would be path energy equals route clear, and it's again positions. And here the start is step. Occupant. Can't read. Scroll to the right. Destination's the same. Visited. Paths. So before I have to call it, I have to remember that we've visited the step we're at. So, oh, and then I have to check if it's visited too. Because we don't want to end up going backwards. So if step is... Hold on. Yeah, it's a visited, insert, step, comma. Oh, it's just a set. I guess I can indent that. Okay. I don't know why I got the search replace going. We need to check if it's visited. Also, if it's not, if we don't find a route, we want to remove that step, right? No, well, I don't need to do that. Yeah, visited is just to prevent us from accidentally going backwards. Well then, no, that is what I want. Right. What was the previous position? Start. Okay, so this should have been start then. I got that wrong.
Honestly, Colin, if you can
In fact, that should be done up front.
I wouldn't s-
Right? No, hold on. We're doing that so we don't end up stepping backwards. Okay, I think this is good. I don't need to worry about loops or anything, so it's pretty simple. It's actually pretty simple.
2 minutes of text, I'm already almost dead.
If the next step is the destination, if it's clear, then we found the path to it, and we have calculated the energy to it, and we know it's reachable. Otherwise, we haven't found a path, right? If the next step is not the destination, but it's clear, then we say we visited our starting point, so we don't end up going backwards and going into ping-ponging between two positions. And then we say if there's some position, if the route is clear from that step to the destination, then I just want to return that then, right? And what if it's not?
Minions.
Then we just continue. Then we loop, right? Okay, so then it's return this again. Actually, then I don't even need this. This could just be new positions and energy. Oh, wait, no, we have to add, right? On the way back out? Yeah. We have to say return that, but then it's path energy plus energy. Let me rename that. This is this step energy, right? Okay. Yeah, so on the way back out, we're adding.
I don't know what this guy said.
Okay, I think that'll work. I just need to construct this visited and paths. So we use route clear a ton, don't we?
The echo's here somewhere. Weird.
What if I make another function that initializes visited for us? That would be nice.
Yeah, that's what I know. Here, I'm scared.
And then we'll have the other one to call itself recursively. So we'll call this one route clear, like with visited. And that goes in the recursive call here.
Dude,
Okay, and then this outer one doesn't have a visited. It just needs to call the inner one with an empty visited map. Positions, start, occupant, destination, B tree et new, and paths.
she's building full AP. I think that's the only thing that
There we go. Mute. Okay. So then these only just need to provide the path, so let's do that. So find possible moves needs a path also. Paths. Let's add it all the way up that we need it. So find possible moves needs it. There. Paths, which means solve needs it. Paths. And then paths. Borrowed. And here, borrowed paths. Okay.
I'm by our gang.
Getting there.
By our gangplank.
A little bit more work. All these places we call route clear, we have to add paths.
Dude, I'm so scared.
Copy pasta everywhere.
And that just.
Everywhere and everywhere. And one here.
At the bottom, the minions coming from.
Okay, so now we just need to construct the path. So let's do it. let mute paths equal b tree map new.
Can't do that.
Paths insert position hallway left 0 to vector
Big shit's
position hallway
Did E over S-
left 1,
I don't know if you do.
right?
E over S-
And then from 1 we can go back to 0, or we can go to hallway. Look at my map again. AB, or we can go to room. Okay, so we can go to position hallway AB, or we can go to position room A3. Okay. Today's gonna be frustrating.
Got them all tops.
You're giving it a go with home romas. Good day. Good luck. I mean. Okay, so let's just go down the hallway. So from hallway AB, we can go to hallway left 1, or we can go hallway BC, or we can go room A3, or we can go room B3. From hallway BC, we can go to hallway AB, hallway CD, room B3, or room C3. Yeah, I really should have done it this way from the start. And I knew I would say that. I just had sunken cost fallacy before. Hallway right 1, C or D. And then from hallway right 1, we can go to hallway this is wrong.
I have a lot of shit.
This should say BC. We can go to hallway CD, we can go to right 0, or we can go to D3. Okay, and now you have to do the individual rooms. So, room A3 can go to hallway left 1, hallway AB, or room A2. And so B can go to hallway AB, or BC, or B2. C3 can go to BC, or CD, or C2. D3 can go to CD, or right 1, or D2. And then the inner rooms, right? So A2 can go to room A3, or room A1. B2 can go to B3 or B1. C, D, C, C, D, D. And then the innermost room. Actually, there are 2 of them, right? A1 can go to A2 or A0. 2 or 3. This is still a bit tedious. B can go to B. Oh, what am I doing? C. C and D, right? Okay, now the innermost room. There's only one path you can... Oh, no, there's 2 paths. No, there's only one path, right? From A0, you can only go to A1. Whoop. A1. What happened? It reformatted it all on me. Oh, there. B0, C0, D0 can go to B1, C1, D1. Okay, and then these paths are copied. So what if I just do a make paths? Because it's common, right? Function make paths B tree map from position to vectors of positions. Paths. Button that up. So this is just make paths. Okay, if I did everything right, then part 1 should still work as is and give me the same answer. Pray that it does. We had a stack overflow. Ooh, not good. That's not good. Stack overflow is not good. How might I have overflowed my stack? We don't need to display that. So perhaps in the solver. So maybe put this in there. See what it's doing. Oh, it didn't even get to there? So maybe in the find possible moves it's blowing its stack? Find possible moves doesn't call itself though. So it's probably route clear. So let's print looking, well, not there. Looking for a route from blank to, well, to blank. You heard my doggy. Yeah. Oh, hello. Hold on, I got to mute the, or not mute, but I have to turn off the camera for a sec. And let me make sure I didn't accidentally mute myself. I need a haircut. Mute my webcam. Yeah, what's the, what was it, hide? What's the equivalent of mute for video? Show, hide, I guess. Looking for a route from visited some things, right? This is probably where I have a bug. Start, destination, paths, or visited. So we just need to have position implement debug, right? That's easy enough. We can auto implement that. Okay, and let's see where the stack overflow happens. It's the bad kind of stack overflow, not the good one that gives you answers, but the bad one where you actually overflow your stack. Oh yeah, look at that. We're bouncing around between room A's A1, the left and the two left hallways. Okay, so it's not, it's the visited is not working. That's easy to fix, right? Visited. Okay. Looking for a route. Get this. Looking for a step. That's not the destination. Oh, I never checked visited. I'm dumb. Yeah. Oops. We only want to go this. So if it's not visited. So how do I do this? If I guess I could put it up here. If visited contains start a step, continue. So we don't bounce back and forth. All right. Now I'm gonna have to remove the prints because it's gonna try all. Oh no, we still panicked. We got a none on line 401. We'll see. Route from visit none. Wait a minute. It did not find a route at all? Route from left to 0. Why? Is it returning early or something? It should have called recursively. Why didn't it? That's probably the okay, so I have some other bug. this is correct, right? But why did it stop? I don't know why it's stopping early. It should only return early if it actually calls recursively. Why did it stop? Room A3 should have gone to A2, right? If visited contains step, so it won't. So it won't continue. It's not the destination. Oh, right. The next step will be occupied, so it won't find a... Okay, that makes sense. It won't find a path. Actually, this all makes sense. Why is it starting in hallway left 1, though? Maybe we just need to print more. Am I printing the right things? Start, yeah. I don't understand. How is that already visiting something? Oh, no, I get it. It first tries to go down the hallway left 1, and then it hits the dead end. Right? And then
Is it just like a funny hat to wear?
It tries to go from... Oh, wait. It can't do that. What it's doing is it's bouncing between... It's going from here to here and then over to here. We don't want it to do that. So I need to insert these hidden nodes then.
We'll try to range them.
Yeah, okay. We need to insert these hidden nodes. I forgot to do that. And we need to make sure that those nodes are not places we stop on. Well, they won't be, right? Because when we're just looking for a position, we only consider these possible places to stop at. Okay, so then it should be fine. We can insert these extra nodes. So this would be like room A entrance. Room B entrance. Room C entrance. I want to put it with the room, actually. There we go. And room D entrance. Do I get all the spots then? Everything covered? I think so.
Oh, kill him.
Yeah. Alright, it just makes it a little bit more complicated to make our paths. Make paths is complicated.
Honestly, you need to worry about...
This is part 2. Sorry, Shershock. Or Endurin. We got part 1 with the skin of our teeth. Is that how it goes? 0 to 1. Right. Left 1 to left. Okay, so we don't go directly to hallway AB. We go to room A entrance. Okay, so yeah, we're just inserting extra nodes, right? There are 3. This makes more sense. There are two directions you can go from here. You can either go left or right. And then I need to insert the node for room A entrance. You can go to hallway left 1, or you can go to hallway AB, or you can go to room A3. And then I'll need to add these entrances between the hallways, right? So this doesn't go directly to either of these 2 places. It goes to either room A entrance or B. And then B goes to either room B0 or it goes to hallway AB or hallway BC. And then C goes to BC or CD or C. Hallway BC goes to room B entrance or room C entrance only.
The double the infights
Okay. It's not so bad.
the ADC.
It was just wrong before because I wasn't considering these room entrances. So it's D entrance goes to hallway CD, or it goes to hallway right 1 or D3. Hallway CD goes to room C entrance or D entrance. Hallway right 1 goes to room D entrance or right 0. Okay. Then room A3 goes to room A entrance. Or it just goes to one of two places. And then I just need to modify, actually these are the ones we modify, right? B entrance or B2, C entrance or C2, D entrance or D2. And these are all the internal room ones. Okay, did I get that right? What about from hallway right 0? Did I forget hallway right 0? I did. We're missing a path out of hallway right 0. Goes to hallway right 1. I'm thinking that we never actually use these and that maybe we can just trim those off the path. But maybe we need them for part 2, right? Try it again. No key found for what? Room A3? Did I delete it by accident? No. Hold on, what? Line 419. Oh, shoot. I need to insert space. The space needs to exist. Right, so yeah. We need 1, 2, 3, 4, right? Room A entrance. These are actually never occupied, but they have to exist. The rooms have to exist. The room entrances have to exist. So that I need that on both of these. Yeah. Okay. Okay, it's visiting a lot now. So I suppose we don't have to print looking for. Is this the point where we have to wait for the heat death of the universe to find a solution? Maybe. Don't know if we'll ever find a solution this way. Oh, no, we panicked. No solutions, right? 604? Okay. So I messed something up. I had a print statement in there for here, right? Let's show these again. Let's pipe that to out text. Printing enough? I don't need to see them all. Okay. Was this 1,000,000 lines? It's at least 1,000,000 lines. It's taking a long time to load. It's using all my RAM. Quick, download more RAM.
I walked into his ult, which I don't really know what it
Ooh, it didn't move. Okay, that's bad. It's not actually it's duplicating itself. Yeah, look at that. It's horrible. Okay, so I messed that up then. Close that file because I'm running out of RAM now. I dropped 245 frames. Did I just drop them now? Probably because it was overloading my CPU. So the problem is when we do a move, it didn't compute the correct
Did you see that? He flashed it.
next position. This new position. This find possible moves is not updating the new position.
Flash to kill. Okay.
This route clear isn't doing it. This one's not doing it. Okay. Oh, that's wrong. Yeah. We don't want to do that there. It's no longer the original starting position, is it? I guess we could, I don't know. I need to have another parameter then. So start twice, and then this is really current position, and then start is just pass through, and current is step. Try that. Oh, now we overflowed our stack. Why? Oh, because it didn't insert the right thing here. This is wrong. This should be current. Current. Alright. Don't overflow the stack now. Number 100 did it in 1 hour and 10 minutes, both parts. So this is a hard one. This might be the hardest or next to hardest one, right? Let me just check out text to make sure it's working again. Oh yeah, so we're finding solutions again. So let's remove the printing again. This one. Oh, not that line. Okay, maybe we'll find our original solution now. And then we're ready to run part 2. Shouldn't it display something? I guess it's not finding a solution. Hold on. Put that back in there. Do this again. No, it found something. Wait, then am I running the wrong part? Am I doing something bad here? Control C. Control C is not working. They drop more frames. Comment that out. Yeah, why is this not printing something now? Wait. Delete. Oh, was I looking at that? Oh no, there we go. We find some solutions. All right. I don't know what I did wrong, but now it's finding the same solution, right? 15.365. Yeah. Okay, so let's try part 2 then. Is this ready? Did I have part 2 ready to go? Hold on, let's check. Part 2 should be the same as part 1.
Well, they're definitely making a season 2.
Only, right, we have extra. We have different things in the last or in the middle two rows.
You literally like give to. Accident. With it.
This is wrong. I knew I had something wrong. It's not 3, 2. It's 3, 0. There. I knew I had something wrong. Right, because it's unfolded and these are the middle two. Okay, let's go for it. Let's go for it. See if I can find a solution. Maybe we can guess before we run out of energy. No, we panicked. Couldn't find a key. So I must have screwed up here. I added entrances for A, B, C, and D, right? So what's different here? A key on what line? 421? That's the same line as before, right? That the positions didn't have a position, but I thought I added that right here. Oh wait, this is wrong. Yeah, I messed that up. These are supposed to be positions. Right? That goes there. Solution actually has to have like all 4. So I can do this in multi-cursor, right? 3, 2, 1, 0. And then these are all 3, 2, 1, 0. These are all A's, B's. A's, B's, C's, D's. And these are all solution. Okay. Just being dumb.
You also really flash up the wall to get me.
Well, good news is it didn't stack overflow or key not found. Bad news is not finding any solutions. Oh, nope, it's finding solutions.
You guys might be able to win this.
It's finding them. It found it. 52,055. Did we do it? Yes! We did it! We did it! Thanks, Shershock. So that was not too terrible. It could have been a lot more efficient, though, I'm sure. Alright, that's funny. So, I'm tempted to leave in the prints. Clean up. I'm tempted to leave that in. No, why bother? Why bother? No, I want to keep them. I want to keep these until I if I revisit this and I am working on making the performance better, I want these in case something goes wrong and I want to print the intermediate steps. So this print is when we find a better solution. This print is when we are if this doesn't give us enough info, this one gives us a ton because it tells us every step that we try. So I want to keep that, but I want to make sure that these run without displaying anything but the final answer. And then since it's after midnight, I think I'll just call it and revisit this some other day. Maybe never. Probably what I'll do is I'll look at other people's solutions and then they'll probably have thought of something more creative than I did. And I'll go back and improve my solution after that. But okay, this is one of those Days where I think I barely squeak by. I got an answer on my own. It's a really horrible brute force solution, but it actually got me the answer. I'm just not clever enough to get it to run really fast. This is going to complete, right? It's not debating me. You're not debating me, are you? You're going to give me a solution, right? It'll never give me a solution now. It just takes a while, right? I just have to be patient. It'll give me an answer. Okay, maybe while it runs, let's explore how people did. Ooh, brutal. Look at that. Huge drop off. So that means I've guaranteed got between 1 and 2,000. Yep, look at that. 3.5 hours and I still got a better rank than I did in the last 2 days. Wow. Okay then. So I don't feel too bad then.
Free kills.
I don't know. What did you guys think? Should I read chat now? I haven't read chat the whole time I've been focusing. Somehow people did part 1 and 2 in 24 minutes because they're wizards. What can I say? I'm not. Today was a rough day. You think so? Anybody have actually now's the time for spoilers. Anybody have insights into how that make it more efficient or a better solution? You really like the puzzle, but it took you a while. It took me 3.5 hours.
Help me.
I'd say a solid half hour to an hour was spent with me avoiding making an edge list. I should have just made this meg pass, this edge list from the start, right? Because then all we really needed to do to expand it is to add these extra edges here, right? Or the intermediate, the unfolded edges here, I guess, is what we're talking about. Actually, that would be exactly these. These are the only edges that are different between parts 1 and 2, right? And I would have avoided a lot of typing and copy pasting along the way. Did this ever finish? No. I must have broken it then. Why would printing it matter? Right? Why would printing matter? All I did was uncomment that. Unless there's something non-deterministic in this. Yeah, all I'm doing is printing. What is different printing versus not printing? I can't think of what it would be. Display positions just borrows. I don't know what's going on. So this is, maybe there's something still non-deterministic about my code. Or maybe there is a bug, but it's finding that the actual answer, and I never bothered it to let it run to completion. But part 2 ran to completion.
They were just both in a bush, and I did my combo.
Weird. I don't know. We like this puzzle, but it took you. Oh, I already read that. I didn't really miss a whole lot of chat, did I? Were there any? Is there anyone you guys got to ban while I was focused? I don't think so. I banned someone when I was not in focus mode. I was asked, are you one of those maniacs that programs for fun? Yes, I am a maniac who likes to program for fun. Okay, I must have screwed up part 1, but that's weird. How did I screw up part 1, but then get an answer to part 2? Now part 2 is not giving me... There's something weird going on. Oh, did I just need to be a little bit more patient with part 2? Was that the answer? This is making me nervous that, like... Okay, there it goes. I just needed to be a little bit more patient. But this did finish, like... Yeah, it finishes... So what? I screwed up part 1 then. Well, now it's printing... I don't understand this. Is this just never completing, and I just... Okay, so part 2 finishes and gives me the right answer. Part 1 no longer finishes, but at least gives me the best solution is the answer. It's just never finishing for some reason. Why would that be? Well, what did I do to screw up part 1? Maybe it's terminal bug? Oh, like it's trying to move the ones that are already solved, maybe? Sometime when do you press enter to print in terminal? Yeah, I might have eaten a line or something. I don't know. Let's look at part 1. I mean, if we didn't have positions inserted, then it would have totally broken. 0 and 1, okay. A3, A2, B3, B2, C3, C2. Okay, looks right. Nothing in the right hallway. Okay. The solution. Oh! Anybody else see the problem here? Oh wait, no, never mind. Solution starts out with cloning the position. So I didn't have. I was going to say I didn't insert into the solution the A, B's, C's, and D's in 0 and 1, but I don't have to because they're copied from positions. So that's not it. So then what is it? Make paths best of. I mean, make paths is the same. Is there a bug in the pathing? I don't get it. I don't get it. I don't get it. Here I had to reinsert everything in the solution. So actually, this doesn't even need to clone it. This is a complete solution. So, oh no, it's not. It has to. Oh wait, I think I might. No. No, I do need to clone because it considers every position, even the hallways and the entrances. But okay, let me just print out that display positions and display positions again of the solution. Maybe there's something weird here going on. Why it's never detecting. Wait, no. If it didn't detect a solution, then we wouldn't have gotten this. So that's probably not it. It's getting stuck in a loop somewhere, right? Print display. Yeah, this one. Yeah, it can't be a problem in the setup. Otherwise, it wouldn't have found even potential solutions. Right. So then what is it? Does it just take a super, super long time to do it? I don't get it. I don't know.
Yeah, that guy's dead.
Maybe I let it run overnight, and maybe it finally terminates. It just takes a lot longer for some weird reason. Okay, I'm just gonna say that that's what it is. It's just gonna take a lot longer for some reason, but to exhaust all the other avenues for some weird reason, and we were just lucky that we found the best. Anyway, what else do I want to look at? See if any of my friends have finished it first, or also. T-Bod did it. Ooh, I'm almost in the top 10 again. A few people have done the last day. Etienne is... I'm catching up on Etienne. I'll only need 10 more points. That's probably not possible, right? They would have to not do the next 2 days at all. I think they won. Oh, I wanted to look at the day stats. 23 minutes. And there's a decent spread. Where is Bataveros? Oh no. Did Bataveros not get it? I don't see Bataveros on the list. Did they fall behind on the leaderboard? No. They got a comfortable lead, like 15 points. Actually, that's not comfortable anymore, is it? Oh, no, they're there. Wait. We're on the wrong day, right? Wait, what? It only took them 5 minutes to get part 1, and Bataveros did it in 9 minutes, but didn't do part 2? How is that possible? Wait, how could Bataveros do it in 9 minutes and not finish part 2? That's crazy. Part 2 wasn't that much harder than part 1 if you structured it right. Or was I just really lucky? Hey, I'm being rated by Anthony Writes Code. Hey, Anthony. How are you doing? Wasn't answer 15365? Yeah. It's giving me the right answer, but it's just never exhausting all the alternatives. Can't stay long, going to bed soon? Yeah, me too. Never got part 2 to complete. I have a weird opposite problem, Anthony. I can get part 2 to complete, but part 1 does not complete. But before I rewrote my solution to work with part 2, my part 1, okay, there, it finally did it. It finished. It just takes a really long time for some reason to exhaust all the alternatives for part 1. But part 2, it finishes fairly quickly. Let me go over my solution since I'm almost at the end of my stream anyway, but I've been rated by Anthony Writes Code. Thank you for the raid, and have a good sleep. I'm sure you deserve it. 3 seconds. Yeah, both my part 1 and part 2 take ages, but ages in terms of computer's CPU counter. In terms of a human, it's not too terrible. It's maybe, what was that, like 30 seconds to a minute? Let me go over my solution to everybody who just joined. So I don't know what Anthony wrote it in. I would guess Python. I did it in Rust. So, and I did a lot of brute force stuff I'm not proud of. So, you guys know the problem because Anthony was working on it, right? So the way I did it is to track the various positions using a map. Probably didn't need to do it this way, but I decided to do it that way. My positions, I just enumerated all of them. The only difference between parts 1 and part 2 are these extra rooms, right? And otherwise, I have the rooms and then the hallways between the rooms, right? And I didn't know if we needed to model it, but let's go back to the problem. These left and right hallways, I put positions there so that it actually tries to use them. I don't know if we needed to do that. The very far left and very far right are illegal in part 1. Are you sure? I was reading through that to try to see that, and I couldn't see it. I think you can use those 2 hallway positions. It just says that you can only go into the hallway once, and then you have to go back to a room, and it has to be the destination room. Did I miss the rule that says you can't go into the end of the hallway? Need 3 spaces to hold enough to swap a row. I didn't even consider that. So maybe I'm modeling the ends of the hallways, but they're impossible to use, or they're not practical to use. So it's possible. Yeah, when you think about it, you put one there, a second one there, and a third one. I don't know. So maybe you never need to use the end of the hallway. So I could maybe speed mine up by removing the deep part of the left and right hallways, right? Probably. So that just makes my solution faster. But anyway, back to my solution. So where is it? Part 1, or it doesn't matter which one I show you, because part 1 and part 2 are basically the same. So I basically fill the space. So all the hallways are empty, the room entrances are empty. For part 1, the outer 2 are filled from the input, and the inner 2 are already pre-solved, right? To make it have parity with part 2. And then the solution is just the same as the initial positions, only we say what we want those outer two rooms in each, or outer two slots in each room to have, and then we run our solver. So part 2 is the same, only it's the outer and inner room that we fill in, and the middle is pre-filled with something that they gave us, and then the solution is completely different than the start. The solver, here we go. So again, probably not the best solution, but what I decided to do is we loop through all of the positions that have an occupant. So if there's an occupant of that position and it's not in its final position, then we find all the possible moves that thing can make that make sense. And for each of those possible moves, we get the amount of energy it would take along with the new layout of the rooms, right? Then we add that energy to the energy we've accumulated so far, and we say, well, if that exceeds the best path we found, we discard this path, because we'll never get a better solution if we've already exceeded the best, right? So this is one shortcut. If we haven't eliminated that path yet, then we recursively call solve, given this new set of positions and new energy, and if that finds a solution, and the solution is better than the one we found, then right now I'm printing it out and updating our best. And so since this is recursive, it has a side effect of on the way out, it's displaying a graph of the moves if we read it from the bottom up. So here's the initial, and then we move a C, which is 100, 5 steps. So it moved out to here, and then we moved a B 5 steps out to here. It looks like, yeah, this solution used both hallway positions, it looks like. And, et cetera, until we get all the way to the top where we should see the solution. Right about there. Okay, it doesn't show the final one, but you can see that it's that A going to that is the final one in 9 steps for that total energy. So that's kind of a cool side effect. But yeah. So I solved it from the high level down. So I first wrote that solution. I knew it wouldn't be the best, but a lot of the days have been good enough. Brute force has been good enough to find a solution without refining it. So especially on these ones where I can't really think of a better way to do it, I just did it in a brute force kind of way. So, but descending into these functions that we need. So final position is just, given what the occupant is, it's in its final position if it's in the back of its destination room, or if it's in the middle of the room and everything behind it is already in its final position too. And it gets a little hairy when the rooms are 4 deep, because it was easier when there were only 2 positions. It was just that. But when we added the other 2, it got hairier. And I cringed while I wrote this because of 2 things. One, there's a lot of redundancy between A, B, C, and D. And also, there's a lot of redundancy between the positions in the rooms. So I could probably make this better. But this was just to check to see if it's not already in the final position, right? And then we need to move it. So we try to find all the possible moves. So what is that? We say, given what it is, if... what is this saying here? Why did I have an if here? This doesn't make sense, does it? Because that's always going to be true. It makes more sense for this one because this is saying if it would be in its final position, if we move to A0, try to find a route to A0. And if we find a route, then we return how much energy it takes to get there. We probably don't need this in this initial if here. We do need this one because inside of final position, it does check if its neighbors are already solved, right? So anyway, again, I cringe to show you this because there's a lot of redundancy, but there are 4 possible places the A could go that we prefer. So if we can find it, we return immediately and we don't explore the alternatives, right? But let's say that we can't get the occupant, the A, B, C, or D to its final position in one step. Then we say, is the next position, what is this? Oh, if we're not in a hallway already, then we can try moving to a hallway, and then the next step we move to our final position, right? So these are all the hallways we're allowed to stop at. So for each one, if we find a clear route to it, then we consider that a possible move. And then going back one, we have this list of all the possible moves we can make. So for each one, we compute how much total energy it would be, and I already said this, but we don't consider that anymore if we exceed our budget, our best energy so far. But if we haven't, we recursively call solve, and it's that recursion, I think, that is killing the performance, and the fact that we're blindly just trying different hallways. Like, just try them all. I said, let's just list all the hallways and try to find all the paths through that, right? This, I bet if I ordered this in a better way and then or made inferences about like the cost, or maybe try to move the D's first and the A's last, probably would have get a more optimal solution. But I'm more of an implementation guy, and I have a hard time thinking of the optimal solution, to be quite honest with you. What else can I talk about? Oh, the some of the convenience functions. So the display is pretty neat to look at, but also pretty gross in a way. Again, could have used some optimization there. A hallway is basically the same. Yeah, these are all the... Why did I have that function? Oh, if we're not already in a hallway. Yeah, I could probably collapse that with that because it's the same list now that I think about it. So let me catch up on chat. If you do part 1 manually, part 2 is a lot harder than part 1. Yeah, probably. Hi there, Funsalot. Bet you can speed up the part 1. The very far left and right are illegal. Okay. I mean, I can try removing that, see if part 1 gets faster. It's not a rule, just something you noticed. Is it similar to NAC spec problem? I don't know. You implement the solution in hardware. That's the ultimate solution, is if you can just have an array of gates solve it for you in constant time. So let's try Anthony's idea. So that would be basically not considering the hallways. So I could actually block them out. I could put something there. There, I put something in that left hallway. Oh, that's not the right one. The deep hallway, right? The deep end of the hallway, which I counted deep, 0, and shallow as away from 0. So put something in the deep hallways. I just have to make sure, yeah, we clone it to the solution. So let's see if that speeds it up. So it's going to rerun it, but not actually use the deep ends of the hallway. Hopefully it doesn't change the solution, just gets faster. Okay, unreachable code. Oh, right. We have to consider those asterisks as something. So on line 151, what are we doing here? Final position. Hold on. Why are we considering the hallway there? We shouldn't be considering that at all. Maybe it's this one right here. Yeah, that's it. So I think we'll just return true. True! Don't touch it. So it's reachable now, but if we see it, then we say it's good, don't touch it. Yeah, that was much faster. Thank you, Anthony. Can we do it when not display the stars? Actually, it's fine. The star actually helps remind me that, like, it's like we put a pillar there at the end of the hallway saying you can't walk there. Oh, I've been rated by Larry NY. Hey there, Larry. Anthony writes code just helped me improve my part 1 solution. We just realized that part 1 you can just block off the hallways and you find the solution a lot faster. So 1001, 1002, 1003, 1000. Yeah, so like, well, it should say 1001, 1002, 1003, 1000. So like less than 4 seconds now. That's nice. 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1000. This is where I should really use the stopwatch. Anybody counting? It's like 16 seconds. This is probably on the order of 30 seconds, right? It's about 25 seconds now. 26. Yeah, so on the order of 30 seconds. You mean today's was really bad? I like Rust. Today, I wasn't struggling with Rust so much. I was struggling with how to solve this problem and how to model it correctly. I spent way too much time handwriting all the possible paths from all of the positions when I really should have just modeled it as a graph. And even modeling as a graph, there's actually a lot of code that looks redundant that I could probably clean up. It's all this stuff. All these paths, right, are all the possible moves you can make throughout that burrow, right? And then I just ended up using a very simple way to search through them. This route clear. So here's where one of the rules comes into play, which I didn't really use to my advantage. I think it's like Towers of Hanoi, where you want to move the expensive ones last. Or another way to see it is the moment you see a way to move it to the destination, you move it. But you only move it to a hallway when you must. Or something like that. I'm not very good at coming up with the solutions. Anyway, I didn't really use this to my advantage. But it's just a simple, if we visited the step, skip it. If it's our destination, then we found it as long as it's not occupied. If it's not our destination, if it's not occupied, we mark that we visited it and then recursively look for a way to the destination from that next step. And along the way, we add up our energy we're spending on each step. So at the end, we get a new position map. Here's another thing that's kind of expensive. I was lazy and just took our whole position map and cloned it, and then just removed it from the starting position and added it to the destination position, and then returned that back out with the total path energy. I probably shouldn't have done this clone. There's probably a smarter way to do this that doesn't modify the start and the end. Probably what I should have done is just return the destination. Oh, no, I don't even need to do that, right? We know the destination. Probably what I should have done is when route clear return something, like in any of these positions, we can, in addition to returning this, we could return the what is it? We could return the destination, right? Yes. So in this case, it would be room A0. We could return it along with the energy. That way, when find possible moves returns, instead of having the new positions already, we could just temporarily add to our current positions the update, and then back it out if it didn't work. Can you return energy spent? Yeah, that's what we're doing right now. We're returning the energy spent in all possible moves. That's what this move energy is, along with what the grid looks like if you take that move, right? Use the time command, but I'm not in Linux or Mac. I'm on Windows. The time command is just says, hey, you want to change the time, I guess. Type it in. And I'm not good enough with PowerShell. I know there's a PowerShell command to time it. I'm just being lazy. Being super lazy because it's like 1 in the morning for me. Thought Rust was meant to be quick. Oh, it's quick. It's just me that's my solution that's slow. Or is it date? No, date doesn't date do the same thing? The date says, oh, you must have a better idea of what the day is than I am. Why don't you type it in? It's not date or time. I think that's a legacy thing from way back when you actually had to tell your computer what time it is. You remember those days where your computer didn't know what time it was because there was no internet, so you had to tell it what time it was? And you had to do that every time you turned on the computer unless you had a battery attached to your CMOS. You don't think about that these days. Like, nowadays, the computer tells you what time it is. Yeah, you say, you could ask your phone, what is the time? It'll tell you. 20, 30 years ago, it was the opposite. The computer would ask you. It's not like in Russia, a computer asks you what the time was. 20, 30 years ago, a computer asks you what time it was. And anyway, I'm happy with Rust. I didn't struggle with it too much. It was mostly just figuring out the algorithm and not wasting a lot of time entering too much redundant code. I think what I could do to improve this is, instead of enumerating every single room like this, we could just have one. I mean, I could literally just do this, right? U size or something. It could be U8. Why not? Right? And then I can maybe collapse a lot of similar cases together and just use the associated data for the enum, right? I might go down that path to improve my program, but it's already pretty late for me. I mostly just want to chat and answer any questions and then raid someone else, since we did find a solution. This one was a tough one. If you look at the stats, not many people have solved it even now. We're like 4 hours into it. Only 1/10 of the people that solved day 21 have solved it after 4 hours, which is a big deal to me, I think. The fact that it took me 3.5 hours and I still got ranked 1300 it means it's a really hard problem. The best I've been able to do was day 5, where I got ranked 534. I know Anthony got like actual score, which you can only do if you get with the first 100. And I almost did that once a couple of years ago, but now it's way too competitive. So, barring any like really super obvious things I can do to improve this, I might just call it for the night and raid somebody else. I'm sure someone else is still struggling on this. It's been almost 5 hours. Wow. I started a bit early too. Let me get set to raid someone else who's still working on this, maybe. Is anyone still working on it, or am I the last one? Browse, creative, software and game development. Well, that's interesting. There's a trending. There are 2 people who are trending up. I guess they got raided or something. We could raid Togglebit if no one else, because he's doing Rust. If you want to see more Rust, Togglebit's awesome. I'm just looking to see. Python C import datetime print datetime. Yeah, but what if the computer doesn't know the time? Okay, Ironista's still going. Ironista doesn't have a stream title. That's why I couldn't find them before. So let's raid them. I might be back tomorrow night to do day 24, but I might not, because we're getting close to Christmas, so I don't know. But thank you for watching. If I'm not back tomorrow night, then I hope to be back soon to finish up Advent of Code. We got 2 more days. And the last day is usually really easy, so anyway, take care, have a good day, good night, thanks for watching, bye!